Ben Fisher's journey in RC aviation is a testament to relentless innovation and technical excellence. From founding the iconic 3D hobby shop to his current role as co-owner and lead designer at Extreme Flight, Ben has consistently pushed the boundaries of what's possible in RC aircraft design. His deep understanding of aerodynamics and a hands-on approach to testing has led to some of the most successful extreme aerobatic aircraft in the past decade. In this episode, Ben takes us deep into the technical world of RC aircraft development, sharing his meticulous design philosophy and revealing the extensive testing process behind Extreme Flight's renowned models. We explore everything from the evolution of RC technology to the intricate details of airframe design that make their aircraft perform at the highest level. Whether you're fascinated by extreme aerobatics and 3D, or simply love the art of flight, this conversation offers a rare glimpse into the mind of one of RC aviation's most successful and knowledgeable designers. Hi Ben, how are you doing?
Hey Juan, how's it going?
Good, thank you so much for joining us.
Thanks for asking me. I appreciate it.
Yeah, I'm pretty excited to have you here. I mentioned this the other day, I've been wanting to have you here on the podcast for a very long time. You are one of the first people I thought of when I thought of the idea of let's make a podcast. So yeah, pretty excited to have you here.
Very complimentary. I think you're overselling me a little.
Well, so I have a ton of stuff that I want to talk to you about. We have a ton of stuff to cover. Maybe you can give a very, very quick intro for those few people that might not know you yet. Who you are, what you've been up to,
Sure.
how you started in the hobby.
Well, there's a lot of people that don't know who I am, so that's fine. So I'm Ben Fisher. I'm half of the team that runs Extreme Flight RC with Tim Hanstein. We're employees of Extreme Flight. When the founders of Extreme Flight, Chris Henson and Melissa, when they retired in 2022, we took over Extreme Flight. And Extreme Flight is an independent producer of ARF, mostly aerobatic aircraft. I've been in the industry about 20 years. Before I worked for Extreme Flight, I had my own independent company called 3D Hobby Shop, which I founded in 2005. And before that, I was trying to figure out how many years I've been in the hobby, but I think my first solo flight was the summer of 1978, I believe. So I've been in RC a while and done a lot of stuff in RC, and then been in it professionally for 20 years. And before I was in RC professionally, I was in different things, mostly in auto racing, and that'll come back into the story later about everybody arrives at where they are via a different path, and it gives them a different way of doing things and different insights, different thoughts.
You've been basically doing this personally for about 20 years. What made you get started on the design of airplanes? I'm guessing that when you started doing this personally, are you talking about designing airplanes or you had something else going on?
Oh, just making my living from the RC industry. I was a hobbyist for years and years. For more than 25 years, I was an RC hobbyist. And I was, buying products and using them and flying them and crashing them and doing all the typical things. And then made the decision, which is still, of a dubious one, made the decision to go into RC as a full-time career in about '05. And, we'll see. Give me a few more years. I'll tell you whether it was a good idea or not.
What was that first plane that you kind of got your hands on the design of?
So as far as designing, I had an interesting, fun, and very fortuitous entry into the hobby. So I'm originally from Texas. Was raised on a farm in Texas. And if you're looking for hobbies to do when you live on a farm, well, one thing you have a lot of is you have a lot of space. And so you don't have neighbors to come over and kick a ball with, but you do have a lot of space so you can fly. And so I wanted to do RC, and I had an uncle my uncle and his dad had designed and scratch built wonderful RC airplanes going back into the 1950s. They were incredible builders, incredible engineers of model airplanes. And so when we would go visit grandma in the summertime, I would get to hang out with my uncle. He would show me his airplanes, and he taught me all the basics. And so when learning RC from my uncle, there was no question about whether you designed your own airplanes. Of course you did, because, you wanted to do them that way. That was an integral part of the hobby. The way that I learned it was the entire process of what do we want this airplane to do? Well, why are we going to design it this way? And so that process of analysis, even when I was a little kid, that's what we were doing, and it was fun, fascinating.
How did those first attempts turn out?
My first solo attempts were terrible, but I had good training. I had the idea, but when you're that young, you don't have coordination and you don't have attention span. But I learned to build from kits, and that was easier. But I was just champing at the bit. I couldn't wait to design my own, and so it was pretty quickly. I was designing and buying raw balsa sheets from the hobby shop and learning how to cover and doing these things and my my entry into RC was a little different than most of the people that ended up being in the industry. Most of my peers in the industry, they're in the industry because they were raised in the industry and they have a history in the industry. Maybe they have parents and grandparents that were in the industry. There's a name, a company, a lineage associated. No, I was doing RC by myself out on the farm, and so I never. There were no competitions to enter. There were no clubs to fly at. It was just me flying airplanes I had built. Very very simple, but also kind of pure in a way. And so when I got into the industry professionally, it was sort of a situation where nobody knew who I was or what in the world I was doing there because they'd never seen me before. Because I was not a pattern rat, I wasn't an IMAC guy. you know, I hadn't ever won Tucson, and a lot of people are like, "What are you doing trying to make your living at this?" Which is a legitimate question, but I managed to stay alive anyway.
Well, so yeah, you talked about 3D Hobby Shop. I know 3D Hobby Shop is not around as 3D Hobby Shop anymore, but even today, even though it's been like many years since 3D Hobby Shop has been around, I still see 3D Hobby Shop planes flying in the fields. I still, when you talk to people about certain planes from 3D Hobby Shop, they often speak very well about those planes. Like I think it had a big impact in the industry, especially in the like medium to large scale size planes, 3D aerobatic planes. How did that get started?
So, the term disrupt didn't exist at the time when we started that. But looking back on it, it's kind of a classic disruption maneuver. So yeah, I've always been fascinated by small business. I've always been fascinated by entrepreneurial activities. And like most entrepreneurs, I had some, false starts when I was much younger. You try to start a business, you're not ready, and you quickly figure out, oh, I don't know what I'm doing. But by the time that I was, in middle age and had experience and was ready to start a business of my own. The hobby industry is what I was interested in, and so I thought, well, let's see what opportunities are there. And I made some of the usual regular steps. You get some distributorships from different companies, and so I had a Horizon distributorship and a Hyperion distributorship, these different things, and opened a storefront, selling low C cars and T Rex helicopters and different things, but that wasn't what I was really fascinated by. I was really fascinated by the airplanes. I've always loved fixed wing. And I was really fascinated by the engineering opportunities because I had done engineering in motorsports and in the automotive industry. And I thought, gosh, I think I can really do this. I think I'd be good at this. And first I started dealing for other ARF manufacturers. I dealt precision aerobatics aircraft, and I couldn't leave them alone. I had to put my own improvements on them and things. I had to remake parts of them. And anyway, I sold Hyperion ARFs, and then I started selling extreme flight ARFs, and that was good because then you're dealing with a quality product at that point. And so then you say, oh man, if I want to design and build ARFs, I'm going to have to match this. It's not going to be that easy, right? And so that was good. And I also got to know Chris Henson, the founder of Extreme Flight, by being a dealer of Extreme Flight. And then I said, well, I'm gonna go for it. I'm going to take the plunge. And so then you do this thing that you never thought you'd be doing, which is that you start to meet people in the Far East. You're trying to speak languages you never spoke, which I never have learned to speak Mandarin with any kind of, and I can't do it. I can't do anything except ask where the bathroom is. But you're meeting people from other countries. You're going places you never thought, and you're trying to figure out well, what do I want in a factory? And you've never, you have no information. It's not like you can go look it up. It was '05. You can't really go to the internet and find anything anyway. But, so for someone with no experience, how do you decide what you're looking for in an ARF factory? But I actually got with some good skilled people, had some good processes, and so designed a couple of, at looking back on it now, not very good airplanes, right? But they're the first tries, and got them in production, sold some airplanes, tried very hard to make it a quality product, and tried to offer really, really, really first-rate customer service. Because if you're starting a new line of ARF aircraft and you're getting your feet wet, oh, you're going to make mistakes. Something's going to be backwards, something's not going to fit. So what you have to do is you have to stay up all night, many, many, many nights in a row, packing replacement parts, helping people out, taking angry phone calls. And so like everybody starting a business, you have those rough first several years. But we survived, right? And then once we kind of got our feet under us and we figured out, okay, we can do this thing. We can bring in containers of airplanes. We can sell them. We can make people happy. We can compete. Then it was time to buckle down to the engineering. And I also had some really good, high quality partners. One of the things that I like to do, I like to collaborate. I believe very strongly in the value of different human minds getting together and collaborating. I think that, yeah, you can get things done if you're all by yourself. Sure, you can accomplish something, but you can accomplish so much more with some differences of opinion and, some discussion about things. So I always like to have collaborators. My first collaborator in the RC world was Scott Stoops. And Scott, really interesting guy. He's not much into RC anymore because he's into full-scale aerobatics in a big way. And he owns several full-scale aerobatic aircraft and owned a Sukhoi 26. Just nice. Fantastic. Anyway, he was a big-time, for me, everything in full-scale aviation seems big-time to me, but he's a big-time full-scale aviation competitor. And he also reviewed aerobatic airplanes for some of the model magazines back when there were model magazines. And so we started talking. He was reviewing an airplane that I was dealing. I think it was a Flyton or something. And we started talking, and we both said at about the same time, man, we could really do a great airplane. I have some great ideas. And I'm like, well, I happen to be wanting to do better airplanes. So anyway, that was my first collaborator. And I've had a lot of collaborators over the years. I was talking to collaborators today, and a lot of people know that collaborating now with Terry Wiles, and Terry is, he's another great collaborator. But I got with that first collaborator, Scott Stoops, back in about 2005, right shortly after we started. And then Scott and I had all kinds of fun cooking up our first airplane together, which was the 47-inch extra SHP. And that was great because we both had the same ideas. We had the ideas that we wanted to make a balsa wood airplane that would be really easy to learn to 3D with. I don't know if you remember that particular airplane, Juan, from back in '06, '07, but it was a disruptor, right? Because it was gentle. It was a 47-inch airplane, a kind of an oversized one, looked a little pudgy. It flew on a 3S 2200 pack, extremely light, and it was so easy to 3D. And so that was how 3D Hobby Shop really had its first big success. And that served us well. And I tried to keep that on most of the airplanes that we did between 2005 and when we finally merged with Extreme Flight in 2015. Over that 10-year period, I always wanted to have a strong, I wanted there to be a strong, continuous strand of easy to fly. Mm-hmm. Always easy to fly. And I think that's part of me having been an individual hobbyist by myself, not being a club flyer at some famous club, right? Not having some hot pilot that could show me how to do things. Always knowing that frustration of, I saw this thing, I'm trying to do this, or before the internet, I read about this maneuver in a book. I read about a Lomshavak and trying to do it. The idea being that you can always make friends, customers, and fans in the industry if you make something easier. So that's kind of one thing I've been known for the last 20 years, is always trying to have some aircraft in whatever lineup I was working on that were really easy and confidence inspiring. And that's what a lot of what people liked about the 3D Hobby Shop lineup. And we still have people that, they're very much interested in what we have, which is confidence inspiring. So, which I'm a big believer in, because I'm not a great pilot. You're a great pilot. I watched every video you ever made. I know how skilled you are, but there are also people like me that are not as skilled. And I think that being an aircraft designer who's not as skilled, I think that's kind of my superpower.
Well, I've seen you. I think you are pretty humble, pretty modest about this too. I've seen some videos of you years ago, and you are a pretty competent pilot. I know nowadays there is like
Oh,
a lot
yeah,
of
I
like
can.
extreme aerobatic craziness. It's a whole different level, but you're much better than the average pilot out there.
Well, I do enjoy 3D. I have made spent part of my life trying it, but certainly the industry, the state of aerobatics as it progresses, it's left me behind. And so the way that I fly, I call what I fly old man flying, old man low and slow flying. And I like, there's a whole group of us. We cluster places on the internet, and we like our old man, low and slow flying. Probably the three high priests of old man flying are me, Tavis Newman, and John Vieweg. And so we hang out on the internet, and we make fun of. But what the XA guys are doing, like our team pilots for extreme flight, some of the maneuvers, the rapidity at which you guys think your way through a maneuver, and the amount of muscle memory that you develop for these incredibly quick procedural stick movements on the XA. I am in awe of you guys. You guys are amazing. I probably will never be able to do that, but I love designing planes for it. Just love it.
Um, the other like pretty, I think, iconic plane that I can think of from 3D Hobby Shop is that white and red sleek. I believe you probably worked with Andrew Jeski on that one.
Oh yeah, yeah. Before Andrew had AJ Aircraft, he and I collaborated. He was one of the collaborators I had for a while. And having all these different collaborators is fantastic, because every time you take on a new collaborator, well, you're learning how they think. And so it was fascinating to work with Andrew for a period of time to see how Andrew thought. And so Andrew had the idea first. He said, I want to do a model of Glendale's Slick airplane. And the Slick is it's interesting. If I want to make an aside here, is I find that there are still a lot of people that they fly ARF model aircraft, and they don't have a full understanding of how these relate to full scale airplanes that really exist in the world. And so I always think it's good to give a little background information. So a Slick is an aircraft, a full scale airplane. It's an all composite monoplane. And there have been several of them built. And the gentleman that was the instigator behind the project is no longer with us, and that's why the project has not propagated onward, is because it doesn't really have a patron anymore. But it was a revolutionary airplane when it came on the scene, because it was one of the first all composite aerobatic, full scale aerobatic aircraft. And then when that aircraft was when it was designed, the first ones had 4-cylinder IO 360 engines in them, but then there were a few built with the IO 540, and so the Slick 540 then would, and that's an unlimited aerobatic competition airplane, and it's got pretty recognizable styling in the full scale. And so Andrew was the first person that had ever mentioned it to me, and I said, "Oh yeah, that sounds like a good idea." So he and I did it as a project for 3D Hobby Shop. It was really successful and really popular, and it remains some people's favorite airplane. And then Andrew, of course, went on, founded his own aircraft company, and he's been successful with that and has become a colleague in the industry. And he does many different kinds of airplanes. And when we merged 3D Hobby Shop into extreme flight. That's what happened in 2015. Myself and Chris Hinson, we decided to merge our companies. We had been, fighting for so long, but along the way of fighting, we had become such good friends. We're like, oh, I don't want to fight with you. So we eventually decided to do a corporate merger, which is, a pretty high concept for the RC industry, but it worked. We managed to make it work. And then one of the first projects that I was handed was, let's do a slick specifically for extreme flight, and let's depart from all of the other slicks that have been designed. And so that was the first thing I did: buckle down and do the numerical work, do the engineering work on the extreme flight slick. And when I was doing that, I thought, well, we've been doing the Slick 540, which that's the full scale designation, right? An IO 540, 540 cubic inch Lycoming 6-cylinder in the slick. I thought we need a new name, and no one had ever put the 580 cubic inch engine into a slick, but you could fit it in there. So it's sort of a fantasy scale designation. I called it the Slick 580 because that was the largest engine that you could have bolted into a full size slick. And so that was just, one afternoon I'm drawing. I'm like, what am I going to call this thing? Slick 580. That makes sense. Well, of course, when we started producing that, then all of a sudden all these companies started copying it and calling their copy the Slick 580, which is something that never existed. I love that. But anyway, we did the Slick 580, and has been one of our most popular airplanes. I know you've flown them, and it's an in the 35% size. It's an extremely hardcore aerobatic airplane, and it's been a winning airplane. And then we propagated that across other sizes. It's not as hardcore in all the other sizes, but in the 35% in the competition 120cc size, it's a very focused.
Yeah, no, the 120 is a great plane.
Yeah, it's very, very capable. So that thing is now we're coming up on it being 10 years old. The airframe now is a 10-year-old thing, and it's still, you'll find it at competitions. You'll find, because it's hung in there as a very competitive XA plane.
Yep. So you basically have seen a big evolution on everything related to RC for the past 15, 20 years, in terms of flying styles getting more aggressive, in terms of airframes being stronger, being able to withstand more forces, bigger engines, even electric engines that maybe they were either not available at all years ago, or people that were using electric engines were like a fraction of the power they're putting out today. How do you think about these changes, and how are you kind of thinking about like keeping up with the development on the pilot skills, the level of aggressiveness, the equipment that people can put in your planes?
Yeah, it makes me tired just thinking about it. That's been, but okay. So as a narrative, it is pretty fascinating. They say that in war there's an eternal battle between bullet and armor, and if somebody invents a better bullet, then somebody invents better armor, and well, this is an eternal battle between abuse and strength, right? Because there have been several of these points along the way in RC aerobatic aircraft where someone invented something, and that something was so much better or so much harsher that it caused all the airplanes to break, and then the designers have to go back and figure out, what are we going to do about that? Like, for instance, the 120cc engine revolution is one. When I first started working with and designing 35% airplanes, we did several of them back at 3D Hobby Shop. The 103-inch Extra 330 SC was one that I did. And so that was designed around a 100cc engine, right? And so everything worked, right? You had the right amount of strength and the right amount of speed and all the different things. And then DA comes up with a 120cc engine. And it's, out of nowhere now, in the same size, you can put this much more power. And it was more than 20% more. I'm sure you remember that. It was better than 20%. It was more than, and so that suddenly then goes on the front of your airplane, and your airplane starts breaking. Okay, well, these kinds of changes come along all the time, and you have to be aware of them. And, when servos kind of suddenly go from being 500-ounce inches to being 900-ounce inches, then, whereas before your customers could put the servo on and they could fire things up, and your the surface could go all the way to the stop and it would buzz, except now when servos are 900 ounce inches and you have old control surface designs, if a customer does that, it just pulls the horn out, things like that. And you have to go back and you have to re-engineer all these different parts of the airplane, all these different sizes. And then the pilots, you guys cause me all this work because you invent these maneuvers and they get harsher and harsher and harsher and harsher. And so now, you guys have actually made these maneuvers so harsh that we're up against the material limits of some things that we never expected, like covering. We're rapidly approaching the engineering limits of what covering material will do, because we're at some pretty fine limits here. There's some pretty fine margins of safety. So I'll tell a story about how fine these margins of safety are. So several years ago, we had introduced to us, we had talked about it for a long time, but finally we were able to, all the technology came together in about 2014, that we could, instead of making our covering schemes out of pieces of covering material that were overlapped, we have the new technology, we're going to print. We're going to print the covering schemes onto the airplanes. And so then in 2014, this is going on behind the scenes, and then we're doing the merger with Extreme Flight, and I'm coming into the stream of Extreme Flight, and I'm bringing projects in from our artists and our designers. And one of the things was we had a 106-inch Edge 540, which had a beautiful scheme for printing that was designed by Aaron Bates. It was called the Demonstrator Edge. You might have seen one of those. Yep. They're black, and just one of the most beautiful RC airplanes of all time. And then Aaron also did a scheme for Extreme Flight, which was very popular. It was the patriotic laser, the red, white, and blue with the stars. And so we had these couple of airplanes that had these printed schemes. And so we thought that we had worked out all of the problems with the printed schemes. Now, as it turned out, those things were really unpopular. They didn't last in the industry because people didn't embrace the additional work that was required to repair them, which is understandable. It was kind of a miscalculation by the industry. Is this going to catch on? And we thought it would, but it didn't. But it's actually good that it didn't catch on. Here's why. When you print on an airplane, so you print the scheme on the covering, you apply the covering, you iron it on, you shrink it, and then you have to clear coat it because the ink is not completely UV fast and it's not fuel proof, and so you put a clear covering, like an automotive clear coat, over the print. And so we were doing this, and then shortly after we did these airplanes, you guys invented XA, and you started stressing these airplanes up into the high teens of Gs. And here's what we figured out is that you can get away with doing high teens of Gs with regular covering because the covering will bow out and then it'll go back in. Like on the low pressure side of the airplane, when you do a slap, well, you're doing a slap, you're up in the high teens of Gs if you do it right. And on the leeward side of the airplane, right, on the low pressure side, if you take a photograph of an airplane doing a slap, the wings are bent a little bit.
Yeah, you can definitely see the V shape of the wings.
And you can also see that the covering is bowed out a little bit on the low pressure side. It's being sucked out. Regular covering will do that, and it'll go back in. The printed covering, the clear coat that we had over there, wouldn't do that. It would take it past its stress limit. And you would get micro cracks in the clear coating. And so after a certain number of slaps, you'll just get pieces of covering that'll go and come off.
Wow.
So by applying another layer that has different characteristics over the covering, we took it outside of its range of where it'll work in XA. Stuff like that. You
really
guys do that to me. Well, this is, people behind us, people say, "Oh, bring back that scheme." No, can't. It's a failed technology, and there's a lot of things that we can't bring back because you guys are just too abusive now. And problem is, you're also teaching all the other customers, guys that would be nice pilots and be nice to their airplanes. They watch your videos and then they start doing that abusive stuff
just
too.
To make your life harder. That's the
you're
only
a
reason why I
bad
do it.
influence, man. You're a bad influence. And all the rest of these guys.
The other thing that makes me think of, I think a lot of people, I don't know if it's actually a lot, but I've seen people often asking Extreme Flight and other companies to, hey, why don't you sell these airplanes as kits, right? Like a lot of people really like the planes, but they want to build the plane, right? And I think I've heard some reasons why this is even regardless of the business feasibility of this, it sounds like it's technically not a good idea to begin with.
So first off, so I love this topic because this allows me to talk about technology. But let's just start off by saying that okay, nobody would buy one of those. The people that are saying you should offer these as kits, they've never looked up the price of covering. If they did, if they figured out how much just the ultra coat to cover the kit would be, they would say, "Oh, no, thanks." They'd never buy it. So if you did produce 100 kits for one of our 35% airplanes, you might sell two, and you'd have the rest of them. You could, put them in your will. But from a technology perspective, the things that we have to do in mass production so that these airplanes will live at the kind of G's that you guys apply to them, they're simply not available. You can't do that in a home shop. Like, for instance, I'm in my home shop here, and I crank prototypes out in my home shop. But there have to be limits here because I don't have the technology that we have in the factory environment. I can't build the wings quite as strong as for the weight that we can in mass production. In mass production, when these wings are glued together, the sub-assemblies are glued, and then all the sub-assemblies are brought together, and they're coated and with glue, and then they're placed into a heated press assembly, and they're assembled under thousands of pounds of pressure. And sometimes you get into a discussion online, and somebody will say, "Well, I would like to build the airplane myself, so I know that it's right." And that, while I'm sympathetic to people's desire to do things themselves, that absolutely will not work with a modern aerobatic ARF airplane. It just won't work because you can't do things like we do in the factory environment. You can't put all of the pieces of a wing together in a heated press assembly and apply thousands of pounds of pressure to it while the glue cures. And that's what's necessary for these things to live at 16, 17, 18 Gs. And so even when I'm prototyping here, it's fairly simple to prototype a fuselage or prototype an empennage. But if you're doing, say, a 35% aircraft wing, well, you're going to have to either we have to have a weight penalty to make it as strong as it is in mass production, or we have to say, look, this is not going to take 16, 17, 18 like the mass production ones will, and we have to do other testing with it. Because if we want to test something out to the limits of what XA pilots can do right now, it's got to be factory built. And this is such a disconnect sometimes when you're dealing with people online. If they come from a kit building background, like if their whole experience of RC is Cardins and Daltons and things, which are great airplanes. I mean, when I was younger, that's all I wanted in the world was Cardin Extra, right? Mm-hmm. I'm a big fan of those airplanes, but they're designed for a particular job, and that job is not XA. Right? If you design an airplane for XA and you're going to put thousands of them out there in the world and you're going to essentially tell people, send it. Well, you can't build them like those airplanes were built before. They have to be built. It's actually the highest technology in wood assembly, in the world. There's nobody else doing things with wood like the modern aerobatic ARF industry is doing. And so when people say, I don't like ARFs, they're not built well, I'm like, well, it's kind of the opposite of that. Whether you like ARFs or not, you could never do this yourself because you don't have the equipment. I can't even do it myself, and I design them. I have to go to China to get the equipment to do it that way. Does that make sense?
Yeah, I still can't believe the quality, the strength of these planes. Like I remember probably 10, 15 years ago, I think by then, in my mind, some of the best planes were like this Hangar 9 Extra 260 maybe. That's one of the first planes I remember being able to enable some of this kind of XA maneuver. Still nothing compared to what we do today, but that was the initial idea. And I remember having problems like bending wing tubes because you just did a simple, pretty mild knife edge spin, right? Whereas now we're doing this ridiculous, what you said before. You're coming on the runway and knife edge at like almost full throttle, and you do one of these like 90 degrees laps that freaks everybody out. And somehow the plane can take it over and over and over. And those crazy crankshafts, and the plane takes it. It's, when I started practicing crankshafts and slaps, I had to convince myself because I was afraid, not about like crossing the plane against the ground. I was afraid of like the plane actually breaking in the air. Like it feels like it is very aggressive. It feels very harsh on all the equipment.
Well, yeah, you guys have accelerated your snapping maneuvers now so much that you've sent us through several different generations of strengthening airplanes just for snaps, just snaps. And so, we've been through. Well, I mean, we just went through another round of doing fuselage redesigns. Like we have the new extra NG, which is it's the going to be the new version of our 104-inch extra NG is coming out soon. It's got new color schemes and different things. And one of the things that we did is we took that opportunity. We said, well, these airplanes are really strong. I mean, that's a much respected XA airplane. I mean, extreme flight 120cc NG. That's up there at the top. But that doesn't mean that it's completely optimized. There's always room, right? There's always something you can improve. And so one of the things that we did is we went through the fuselage assembly and said, let's look at it one more time. How many times have we been through this assembly? Let's do it one more time. And so I went through one more time and redrew some pieces. And you're always looking, can I improve a radius? Can I take a couple of parting lines and can I move them with more displacement between them? What can I do to lower stress? Because the stress moves through the airplane. It starts at the wingtip. When you initiate a snap, right? You at wingtip, you have this departure at the wingtip, and it causes an angular acceleration. And then that then moves to the wing tube, and then it gets transferred to the fuselage sides. And from the fuselage side, it then moves back through the tail cone of the airplane. And that stress is at a certain level, and then as the load is at a certain level, and as the tail cone tapers down, the strain gets higher and higher and higher. These things give me nightmares, man. And you get down to that narrowest part of the tail cone, right? Because it's supposed to be a beautiful, swell, narrow-waisted airplane. And you get down to where the airplane's only about that big, and all that stress from that big wing is there. And it's trying to twist the airplane in two against the inertia of the tail, right? So then you lighten the tail, and you make the tail lighter and stronger, and you take weight out of the tips and out of the tips of the tail. It's a constant battle, right? And if we don't keep fighting this battle, you guys will break the airplanes. And that's what happens. So, yeah, you have to kind of hold all these pieces of the airplane in your head, right? This exploded view. And you have to think about, well, where does the load go then? Oh, okay, then it goes where? And it goes from this piece to where? What does that piece glue up against? Because that piece is going to apply stress. And, there's places where you want the airplane to be really, really stiff and really, really rigid. And there's places where you want the airplane to have a little give. This is at least several times a year online. It comes up. Somebody says, I don't like ARFs because they're built with hot glue. Well, so the thing is that one of the best tools that we have is the adhesives industry and the engineers that work in the adhesives industry. And if we go to these guys who are geniuses, they know their stuff. And if we say, look, we've got this joint and this joint's breaking and here's what we're doing with it. And they'll look at it and they'll take it to their lab and they'll come back and they might say, well, we want a polyurethane adhesive. Well, I think we want an epoxy adhesive. But sometimes they say, I think we should go with a thermoset. That's a legitimate technology, right? Because sometimes melting something in and letting it solidify with temperature is the best way to get a vibration-resistant joint. Oh, man. I wish the whole world could build one of these and see what goes into this because it's so much that goes into it. It's crazy.
Yeah, and to me, like the other thing is that it's so rare these days to see airframe issues, right? Like you used to have a plane that like a rudder would like split in half because somebody did something weird. Like they are really strong these days, despite the abuse we're putting them through.
Yeah.
And the same goes with other parts of the gear of the planes. I think like servos have gotten, they're not perfect, but they have gotten definitely much more reliable, much stronger.
But they're so much closer. They're so much closer to perfect. I mean, when you think about, so yeah, my experience in RC goes all the way back to the 1970s. The people that taught me to fly, their experience goes back to before servos, right? To rubber band escapements and things like that. then my experience starts when giant analog servos, and then I've gotten to see how the digital encoder revolution, the brushless motor revolution, servos. It's great. I've been waiting my whole life for servos to work this well, and it's really interesting to see the opinions of people. They come into the hobby lately, and I think it's wonderful that they can just take for granted that servos are nearly perfect. I'm like, oh my gosh, you have no idea what it took. These things are such incredible inventions. Like the idea that we have a standard case size 800-ounce brushless servo that's really accurate and will last for multiple flying seasons. Oh gosh, I can't believe it. But
not having to use so many of them per surface, like that just makes everything so much easier to set up, so much more affordable.
well, I like to tell people, I think these are the good old days right now because everything just really, really works well. I mean, we can buy engines that really don't require any work. They pretty much start out of the box. Maybe you've got to tweak a needle a little tiny bit. You can go to the internet and you can download a tuning guide that makes it really easy to do that. The props that you buy are super high performance. They're pre-balanced. They're pre-drilled now. You can buy the spinner. It's color matched to your airplane. The firewall has a drill guide. You just drill holes and you mount whatever engine you want on there. You pop servos in the holes. You don't have to change the hardware on your airplane. It's all the hardware that comes in the box is all good stuff. And the airplane is designed and tested. These are the good old days. I mean,
Well,
this is good stuff.
the fact that you can get one of these, let's say, one of these 67-inch RXR planes, you set up in, I don't know, half an hour, and you're flying, and you're not just flying a plane that flies well. You're flying a plane that is like top of the line in terms of quality, in terms of flying characteristics, right? I would have loved to have had something like that 10 years ago, right?
Oh my gosh, there's just the idea that would ever exist in RC. It is kind of unbelievable. Somebody as old as me. I mean, I'm an old man now, but but I'm so glad this is where the industry's come to because there were times along the way when you look at the things that threatened the hobby along the way. Somebody say, oh, they're not going to be any more balsa trees. There's not going to be any. It's all going to be outlawed. They won't be able to transmit. You won't be able to have. If I had $1 for every time the death of the RC industry was prophesied, I could at least go out and have a nice steak dinner on it. But as it turns out, people continue to be really interested in RC airplanes, and we continue to be able to build really, really good ones. And so, like I said, these are the good old days.
One of the things I often enjoy reading about is when you post in Facebook updates about the kind of work in progress prototypes, how you are doing different, maybe different wings, different stack positions, different surface sizes when you are doing flight testing of any model. I'd love to kind of hear more about your design process. Like, how did you go from I have this idea, what this model that we should do, to let's design it on the computer, to let's do a prototype, to let's test it, to actually let's put it out there in production. How's the general kind of process look like?
So I love that. That's my favorite thing in the whole world, this design and development process for these model airplanes. That's what really invigorates me. I mean, I have my business partner, Tim, is a businessman. He's invigorated by the business of RC. He loves it. And that's great. And I'm so glad that we have this kind of division of labor in the business because he concentrates primarily on the commerce aspects of it, which he's amazing at. And I get to concentrate more, with my love of the technology and of design. And so I came into doing this work in RC after I had already done this kind of work in other industries. And I spent a lot of my time. So, for instance, in school, I was an absolutely terrible student. When other students were buckled down and they were studying engineering and studying so they could have good careers and make a lot of money, I was at the racetrack. I'm just going to admit that now. I was not where I was supposed to be. I was not in class. I was not doing projects. I was at the racetrack. I was racing cars.
Sounds more fun than class.
Yeah, but that's the thing. You're young and you make some bad decisions and you don't always make those long-term investments. And so, but I was so fascinated by auto racing because growing up on a farm, there's not much going on the farm. It's not a very exciting environment. And then when you get, so fatefully, I went to school at Texas A&M, and Texas A&M is also in the middle of nowhere in Texas. But there happens to be the one thing that there was in that town was Texas World Speedway. Somebody had built this giant track that was built to Formula One and IndyCar and NASCAR standards out in the middle of nowhere in Texas because they thought people would drive across the state to go to races. Dumb. Didn't happen, but it was there. And so there was this giant world-class auto racing facility that anybody could rent, and they did. And so every time somebody rented the thing for testing or a team came in, I'd run out there and I'd try to get hired, and sometimes I did. And so I was like, oh, I'm going to work in auto racing. I didn't realize at the time what a horrible job it is. It's a really terrible job. But I was fascinated by that. So I spent all my time at the racetrack. And in racing, in auto racing, it's all about testing, right? You want to beat the other guy, and so you want your car to be better, and so you theorize about how to make your car better, and then you go and you test, and you have a testing methodology, right? You say, we're going to test these parts, we're going to test these processes, and we're going to do it in such a way to get good data. And the way that you get good data, the most basic thing is you don't tell the driver what the setup is. The testing is done blind. And so the first thing I've learned is that you can take the greatest driver. It's just like the greatest pilot, like the greatest skier. And the thing is that guy is probably so good that he can drive around, he can fly around things. If you don't tell him what you've done to the car or the airplane or the motorcycle or the skis or whatever it is you're testing, you can then get pure results. If you told the driver, well, we, put a bigger engine in, then, he's expecting that and he's going to compensate for that. Whereas if you don't tell him what you did, maybe you change the camber on the right front tire by half a degree, and he goes out and drives the car and he comes back and you say, what did you feel? And then he says, well, it seemed to do these things better and these things worse. Now that's scientific data that you can use. So coming up through auto racing, I had always had this principle of, if we're going to try to make something better, we make it better through design and then testing, right? It's not wishing and hoping. It's not saying, I think I've done a great job. You have to prove it, right? It's very much a show me type of environment, type of culture. And that's what I think that's one thing that it definitely does help me. It served me well in my career in model aviation, is whereas a lot of people that are involved in the hobby, it's like, oh, this looks pretty and this flies nice, and we all agreed that it flies well, so we're going to put it in production. And I'm usually the guy that's there with the clipboard saying, no, we're going to
numbers,
test
actual data, yeah.
Right. We're going to test all three sets of wings. We're going to test both of these airfoils back to back. And then many, many times over the last 20 years, pilots have said, which wing am I flying? And I say, you don't get to know that. And they're like, why? So testing methodology, testing things in a scientifically rigorous fashion, and applying what we know about psychology to those tests, that's what I like. That's my favorite part of this. And it's that has served really, really well, because in model aviation, we don't have a lot of tools. I mean, I don't know about you, but I don't have a wind tunnel. I don't have one here in my shop. We don't have one at the warehouse. No one's offered to give me a wind tunnel. I don't have access to that kind of data. And so what we end up doing is doing empirical testing out at the flying field. And so extreme flight, this is one of the things I like about extreme flight. Extreme flight has a long, long history of this. Extreme flight has always been the company that flew their airplanes in testing. And so this has been a tradition, and it goes back to the founding. And Chris Hinson, the founder of the company, what's one of the things that I always really respected about him is he also had a testing methodology. And he came at it a little differently, because Chris was a great IMAC pilot before he ever founded Extreme Flight. And so for Chris, it was a personal thing. He was going to do the test flying, right? And so with me, I'm not a great pilot. I come at it the way we do in auto racing. The guy that's driving the car is not the engineer. The guy that's driving the car is the driver. There's an engineer, but he's standing on the pit wall with a clipboard, right? It's his job to keep things organized and pure. Well, I tend to look at it a little bit more like that. When we're out doing testing, I'm not wishing that I was the the test pilot. I'm glad that I'm not, because I get to be more objective. Anyway, but okay, well, the question that you ask is about the process. And the process, okay, so the process has to start in consultation with the business side of things. And so, what do we need? And like, for instance, a couple of years ago, we said, well, we think the technology's here. We think we can have this new size of airplane in our lineup, a 67-inch. It could have been 66 or 68, but it ended up being 67, the standard wingspan. We said, we think we can have this now. There's good power systems available. T-Motor was the one we were looking at there. There's good servos available from a couple different companies, Savox and Theta and different ones. We said, we think there's an opportunity. The lipos are certainly common. That 6S 5000 size. Everybody has those. And, they've long been popular in helis and different things. They said, we think we can do this. So now, if we know what this product class can be, we decided we're going to have this product class. Now it's time to make these things exist, right? And so then the aerodynamic theory and the aerodynamic research starts. So then you have to say, well, what size should it be? How heavy should it be? What should the area be? What should the length be? What are some likely airfoils that will work at this? What are we shooting for as far as cubic loading? And then once you have your theory in place, then you say, now let me give myself at least 2 or 3 alternatives for each one of these hypotheses. If I think this is the cubic loading we should have, let me do multiple sets of wings so that there's different cubic loading. If I think this is the tail moment we should have, let me give myself a little bit of a fudge factor here. Let's be able to move these things around. And so if you're planning a testing session, a master testing session, and like with the 67-inch airplanes, we did a big master testing session around the first design, which was the 67-inch Extra 260. Now, what we learned out of that, those questions then are answered for the 67-inch series. We know roughly what that series is going to want, right? Some of these things then become constants and they don't change. Like if you look across our 91-inch airplanes, well, there's a lot of commonality there. If you look at our 104s, there's a lot of commonality because once we get it right on one aircraft, well, some of those things remain constant. Others are going to be variables that give the airplanes their individual personalities. But a lot of it we know, this is the size wing tube that it takes so that the aircraft can do high Gs without too much visible bending. It doesn't overstress the socket, et cetera, et cetera, et cetera. So once we did the big test with the 67-inch Extra 260, and we chose the airfoil that we wanted, we chose the cubic loading that worked there, we chose moments and things, that then becomes the constants. And we use those across the entire 67-inch lineup. And out of that test, what we actually ended up with was a new aerodynamic package with new airfoils, new damping ratios, new things. And then we started using that on other sizes of airplanes. So it gets really complex. If you go to the tree of what all happens in testing, it gets really complex really quickly because you'll learn something on a test for one airplane. You'll say, oh, I didn't know that before. That's amazing. I wonder if that'll work on 120cc. Oh, it does. Well, anyway, then you can propagate these things out. And that's what's happened since that initial test years ago now. On the first batch of 67-inch Extra 260s. That was a fantastic test. We learned a whole lot. And I forget whether that was in 2021. Anyway, I know it was winter, but we learned so much during that week of testing that it really has informed a lot of what we've done since then. And like we were just in China in October a few months ago, and we were testing new aircraft in new sizes, and those are using the Gen 5 aerodynamic package that came out of that test 4 years ago, 3.5 years ago, for that original 67. Okay, this is where I start to talk really fast about it. Testing, I get so excited. I'm going to settle down and let you ask the next question.
One of the things I wanted to ask you, you mentioned how you do these testings. You're testing like 20 different variables. You end up finding the couple of things that you like, and a lot of those things end up kind of translating across all the different models from that size, sometimes even to different sizes. I'm kind of curious, especially when you're looking at all these planes that are modeled after full-scale models. So, when you're looking at the Extra, that's maybe it's a bit different, but you're looking at the Extra, you're looking at the Slick, you're looking at the Laser, that have a lot of things in common between them. I'm I'm guessing that there has to be some, it has to be challenging to figure out how to make these planes kind of different enough from each other that it makes sense to have them as different designations, right? But
Yeah.
still make sure that you are grabbing those good things that you found, right? Like I could imagine a situation where you find the best wing profile, the best stab location, the best surface size, and you have this amazing plane, which is awesome. But now, when you want to make a second, like a different model, how do you avoid just designing the exact same thing with a different
Yeah.
color
How do you
scheme, right?
rhythm?
Like you want to make it different, but you don't
Yep.
want to make it worse. So how do you
Yep.
handle that trade-off?
So so this is there's a happy circumstance here, and the happy circumstance is, let's see if I can explain this correctly. So anyone that tells you, anyone in this industry that tells you that they actually understand what's happening with the airflow around a model airplane is lying. No one really understands. The flow field of air around a model aircraft, particularly a prop powered model aircraft, is so complicated because you have this disorganized, chaotic, spiraling blast of air. Trying to figure out, trying to model exactly how that air interacts with all of the surfaces on the model airplane, inboard of about 1/3 wingspan, anywhere in that thrust cone from the prop, trying to really understand and really model that, maybe in this glorious new age of, personal mainframes and AI, maybe, but I doubt it. Right now, it's very difficult to get a mental handle on what's going on in this chaotic flow regime. So you have to do very blunt empirical testing on things like tail moments and tail areas and things like that. But one of the things that happens in this glorious chaos that happens around the center of the airplane is the different shapes that the full-scale airplanes have when they're brought into the models, and when the models are styled so that they're recognizably, the full-scale aircraft, the difference in feel that gives you to your controls is automatically different. So, as an example, two of our aircraft that are extremely similar aerodynamically, if you look at them so any one of our designs can be reduced down to a spreadsheet. Right? What's the tip airfoil? What's its maximum camber? What's its thickness? What's its chord? What's the, percentage of the chord, its aileron? And you take that kind of data. You can reduce any of our aircraft down to a spreadsheet about 3 pages long, right? And if you take our 104-inch extra NG, and you take our 104-inch laser, and you reduce those two airplanes down to just their spreadsheets, they look identical. However, and you probably have flown both of them, people that have flown both those airplanes, they would say, oh, no, those are very, very different aircraft. And people will go on for quite some minutes telling you what the differences are between the NG and the laser. And I've flown them both, and even though I'm not as skilled as our team pilots, oh, yeah, they feel very, very different. And people will get extremely opinionated about whether the NG or the laser suits them better and which one they feel is better for their flying style. And once they decide, they will not come back from that. But this is the thing, is those two aircraft on paper are identical. On paper. But they're radically different in how the airflow, particularly off the prop, interacts with the shapes, the very different shapes of the fuselage, the canopy, the turtle deck, and the tail. The rudder profiles are different. The stab profiles are different. The fuse profiles are different. The cow's very different. Canopy is very different. And so each of them ends up with its own particular personality, even though on paper, mathematically, it's the same aircraft. Now, you're getting into very fine degrees. And, if you take a beginner, take a guy and it was his first aerobatic airplane, he's going to say, oh, these are great. They feel the same. But you get to a guy at your level, team pilot level, you guys can feel the differences. Even I at my level can feel the differences. And that's down to the differences, the subtle, chaotic, unmodelable differences in the flow fields around the fuselage and the tails of these airplanes. And so that's one thing, is even if you aren't trying, because the laser design predates my time with the company. That was the laser was already in production. It was rolling, and a very much loved airplane by the time that I joined Extreme Flight. But then when I came in, I got to participate in the NG, and so that was great. And Chris and I worked on the NG project, and we weren't going into that thinking of, ooh, how can we make this different than the laser? What we were going into that is, how can we take the NG shape, the beautiful, beautiful Mirko Pecorari designed curves and all of the, how can we make that as practical and high performance as we can? And, we knew what our winning numbers were in that size category, and the laser had winning numbers, but let's use the winning numbers. It still ends up looking different, feeling different, flying different, and having different fans. Okay, so that's one side. The differences are sometimes automatic. Now we'll go to the other side. Take something like the new 104-inch Extra 260. That, from its outset, from the very beginning of that project, I wanted it to be different. The idea with that project is, let's set a goal. Let's set a really high goal. Okay, can we make an airplane which is so good that at the same moment it can be the favorite airplane of beginners? It's their first giant scale aerobatic airplane. Can it be that gentle and that predictable? And at the same moment, can you have a significant number of pilots pick that airplane to fly in freestyle at Tucson? Okay, so then if you had started out with that, would you have said, okay, that might not be a possible thing to do? But that's where you're not dealing with chaos. You're not dealing with random variables. In that case, what I was trying to do with that is, let's look at the deficiencies that an airplane like the NG has for a beginner, right? What is it that aggravates a beginner about that? And then can we mask those without taking away any performance? And so that was a great brain teaser of a problem. And it was a big deal, and that required a lot of work and a lot of testing, a lot of work and a lot of work and a lot of sessions with the team pilots. But we eventually end up with something that is, I think, you can say genuinely is next level because it achieved both those goals.
That's very interesting, because I was actually planning to ask you about this, because it feels also like one of those things that are at odds with each other, right? Like you as a company, you want to put out the best planes for your customers, and at the same time, you want to be able to showcase how good this plane is when you have team pilots at events, either doing demo flights or doing competition flights like the shootout. And yeah, the reality is that most pilots in most clubs aren't doing rifle rolls 2 feet from the ground, right? They are doing basic aerobatics. They're starting to get started with some Harriers, some hovers, and it feels like very often you would have the ideal plane for each of those pilots be very different. So how do you prioritize one or the other one? You want to be able to have like a really cool marketing video, but you also want them to have a really good experience if they end up buying the plane, right? Or they get the chance to test it. What were the main kind of learnings, if you can share, with that 260? Like what did you find that kind of helps those kind of more beginner 3D pilots that still applies well to a like pro pilot?
So you can watch. I think if if you take somebody like me, I've just dived into aerobatic RC airplane design. I've dived into that. I think it's deep as it can be dived into. I've obviously spent an inordinate amount of time in my life dealing with RC aerobatic airplane design. But I think that there's some truths that come with that. If you watch somebody have a career, like I've had a 20-year career and been working with RC airplanes, I've also watched the other people, my colleagues in the industry, right? Whether we're friends that talk about it all the time or it's just some guy that I watch. I think you can see people move through eras. I think you can see them move through discrete things. You can see the guy that starts to design airplanes and you say, all right, what's he going to do? And you can see that he'll pick up different things and he'll become very enthusiastic about one point, right? Like you, for instance, nearly everybody that designs airplanes, they go through a phase when it's all about yaw stability. They think, oh my gosh, everything is Dutch roll. I don't know if you know what Dutch roll is. Dutch roll is a yaw instability that propagates into roll, and you can see jets doing this and they're trying to land. Okay. And so they, oh my gosh, everything's about yaw stability. And then you notice that guy's airplanes for a couple of years, they start to grow all of these strakes and fins on the bottom, and everything is extra rudders and pointing around. Okay, you go through a period of time, and then I think you mature out of that. And then you go through another period of designer, and you say, oh my gosh, everything's about attachment at stall. And all of a sudden, everything you design has Vortilons and vortex generators all over the leading edge of the wings. And that fetish goes on for a period of time. And, as somebody that's been doing this for a while, I can watch other guys saying, oh, you're in that phase. Oh, you're in this phase. You're in that phase. And say, okay, what phase am I in right now? Well, I'm in what I call the damping phase. So we'll start out with what is damping. So if you have a motion and the motion is an oscillation, then if you remove energy from that and you take the amplitude out of that's damping, right? Damping is taking energy out of an oscillatory motion. You put a shock absorber in a car. If you don't have a shock absorber in a car, it goes over a bump. It takes up an oscillator. Then you put a damper. And you put a shock absorber, which is a damper, and it takes energy out of that so that the car doesn't bounce around. So when I worked on race cars, if you're in auto racing and you're trying to go around a track really, really fast, damping is critical because the car is going to hit a bump or it's going to hit a curve the car has to settle down. Right? Because it has to do something else now. You hit a bump. Okay, that's great. Now it's going to go over that bump. But now there's a corner to go around, or there's a braking zone, right? There's something happening immediately afterwards. So you have to regain control, right, of the car. Keeping control of the oscillatory motions of this vehicle, which is, perched up on springs and, it moves around and it does things. And as a result, the tires do these. Okay. Getting control of the motions of it through strategically applied damping forces, that's a big part of auto racing, right? And every auto racing team, if they don't have a shock man yet, they're trying to afford one. And as soon as they can afford one, they'll start dragging this guy around to all the racetracks. And he'll be in the trailer and he has this dynamometer and there's a shock on it and he has that. And he lives his whole life of trying to get the perfect damping force on this car. And then the driver comes back and says, oh, it's amazing. I go over this bump and I can immediately hit the brakes. And he knows he does his job right. Okay. I think I'm in my damping phase of design. This Gen 5 aerodynamic package is all about damping because a lot of what defeats people is unwanted oscillatory motions in their airplane, particularly in roll. And the most obvious one is wing rock. Right? Wing rock and Harrier. Wing rock and Harrier is an unwanted oscillatory motion. And it's interactive with pilot-induced oscillation. It is interactive with Dutch roll. It's interactive with yaw roll coupling. Okay, so it's this very, very complex topic of how do we keep an aircraft stable and how do we avoid oscillatory motions, which take away pilot confidence. And, how do we do it in a bunch of different speed regimes? Well, at the same time, giving the pilot what he wants as far as roll control, roll initiation, both axially and in snaps, and stopping both axially and in snaps. So all of these things they're all tuned by force and damping. So then how do we apply force in this axis? Well, we apply the force with our ailerons. So then the design of the ailerons is one of the things we're working on. And then we damp. And how do we damp? Well, we damp by knowing that air is this viscous, syrupy stuff, right? And so if we start an aircraft rolling and we let off the ailerons and we take away the force, the aircraft will stop rolling, right? Because the air is this viscous, syrupy stuff, and the wing moving through the air experiences drag. So now, in the most basic way, you can see that some aircraft are set to damp very, very highly, like profile planes with big square wings, or, kind of training 3D airplanes with great big square wings, right? They have a lot of area out there near the wingtip, and so they push these big wings through this viscous, syrupy air. It's very highly damped, right? So then an aerobatic aircraft is designed to compete. You have this knife edge that it's on. It has to initiate rolls and initiate snaps. So it has to act like it's completely undamped. And then when the maneuver ends, it needs to be very highly damped, right? At the same time, it needs to exhibit an over-damping characteristic in lower speed and post-stall flight so that people don't have to chase the ailerons while it's harriering. Okay, so what it really is it's the same challenge in designing an airplane for perfect damping and designing race car parts for perfect damping. You want the aircraft to be extremely sharp on control input, right, to act undamped, right? And then when you finish the control input, or when you finish with the excursion, whether it's a bump in the road or whether it's a turbulence in the air, you want the aircraft to be extremely highly damped and very tightened down so that it doesn't keep making unwanted motions. All right. So balancing damping forces is where that 104-inch extra 260, that's where that project came from, really. And that's what's different about that from our other aircraft, is it's everything about the wing is designed to give the exact damping forces that we want when we want them, for the damping forces to go away when we want them to go away, and for them to come back with a vengeance when we want them to come back. Does that make sense?
Yep. It also makes me think a bit about the a different kind of potential area where this kind of applies, maybe in a different way, is the pitch axis. Like when I think of the 120 Slick that I was flying, I guess 2 years ago or so, versus the new 260. I think one of the other things I've noticed is the Slick had significantly more inertia and pitch axis. So in some ways that's beneficial, right? When you're looking at things like crankshafts and you're doing like you want that aggressiveness when you're doing those type of, like, you're pushing the elevator of a sudden in a slab, right? But at the same time, you want it to stop as soon as you release the stick, right? And I recall that the Slick did have a bit more kind of inertia on those maneuvers when you stop, and you have to kind of counter that either with a good amount of opposite elevator or
Yep.
maybe releasing elevator a little bit before you get to the next position that you want. And I think that with the 260, I think some of that has been definitely improved.
Exactly. Now that's right on the money for what we tuned it for, and that Slick it's a good counterpoint to the 260. It remains an evergreen airplane. It's like I said, it's 10 years old and it's still selling at very high rate, but it tends to sell to the more aggressive pilots. And it's we let for instance, our team pilots, we don't tell our team pilots what to fly. We do all these different aircraft, and they have their own particular, like, for instance, Antonio de Souza is a laser man. He's in love with the laser. It's going to be the laser till the end of time with Antonio de Souza, and that's great. We don't tell him, you need to fly this other airplane. We let these guys fly what they want to. And it's interesting that there's a couple of guys that use the Slick on the reg, like Neil Kapalorek. You'll find him flying the Slick a lot of times because Neil is an extremely aggressive pilot. I presume you've seen his horizontal pinwheel to landing.
It's pretty awesome. Need to put some time on the sim to try that out.
That's a maneuver the Slick does really well. I mean, other aircraft will do it, but it's a good Slick maneuver because the Slick is so unhinged, and it's not overdamped, not overdamped at all. Whereas the extra 260 is highly damped. So then, but if you take a pilot and they like that damped feeling and they can use it and they can design a routine around it, like Yuhei Suzuki did at Tucson this year, then that was definitely a routine that was designed for that airplane because it highlighted the strengths of that airplane. But he came within a whisker, almost took it. And so, what a great job. So we don't tell the guys, you need to fly this airplane because we want to sell this airplane. Because no, they're serious competition pilots. They're going to have their own ideas about what they want to fly and what maneuvers they want to fly. But it's interesting because they don't all tend to pick the same airplane. They tend to, they change. I mean, Jake Arnold over the last couple of years has been through a couple of different airplanes, and kind of think, what's he going to fly this time? It's going to be very interesting. So,
well, a very common question I know, because I even get asked this question too, even about extreme flight. Is related to this, actually, to which model should I pick? Or like I'm in the market for people usually have in their mind this size airplane. They just don't know which one to pick. They all look cool. They all fly great, obviously. And as you just mentioned, a lot of it is personal preference, right? Depending on what type of pilot you are or what you are optimizing for, this might be a better fit than that. But I wonder if you can give like a very brief kind of summary of which plane fits best to what kind of flying, or we've touched a bit on the Slick and the 260, but in general across the line, the NG, the Slick, the laser.
Sure. Yeah, actually, and it makes sense that this would be one of the most important things to do if you produce a line of products and they're similar, then you're going to have to answer this question. So the very first thing to say is that we first need to start with a size. What size airplane does someone want to fly? What can they transport? What can they afford? And the answer is, of course, 120 cc. If there's some reason not to buy a 120 cc airplane, that's great. We can go talk about something else. But the answer is 120 cc. The answer is always 120 cc because that's a high point. Right now, there's two high points in performance. There's the 67-inch size 6S 4400 batteries. That's a peak, and then the 120 cc size is a peak. Now those. Yeah.
I 100% agree. Like when people ask me, I tell them, hey, 120 is my favorite by far. Like it's just such a good balance between, it's expensive. I'm not saying it's cheap, but it's within reason. You're not going into one of those like 120-inch planes that you need like a giant car, giant trailer, and they are big, visually big. They have this like bigger plane feel where the wind is not that big of a deal, but still they are super aggressive, right, in comparison to a 120 in general. And then you have this 67-inch, which so much cheaper, so much simpler, so much easy to carry, and surprisingly they fly really, really well. Like it's the biggest convenient electric size you can get, in my opinion, right? You still have a 6-cell pack. You don't have to be getting like these giant 12-cell setups. And they fly surprisingly well for the size and the manager.
Yeah,
into it.
What you can do with a modern 67-inch airplane like our Extra 260, our Extra NJR laser, what you can do with that and a simple single 6S 5000 battery, if people haven't been paying attention, they'll be shocked at how good that setup is. But for the purposes of discussion, we're going to pretend that everybody can afford a 120 cc airplane. Everybody's got a trailer. Okay, so if people can do that, then in that class, because that is a very popular class, and we sell a ton of 120 cc airplanes, then the answer is laser. It's just like if somebody says, "What kind of car should I buy?" and if you want them to be your friend, say Honda. Right? You just the lowest risk thing you can possibly say. What kind of generator should I buy? Oh, if you want this guy to be your friend, say Honda. You're going to win that. If somebody says, what kind of airplane should I buy? Then what we normally do is we start with our baseline aerobatic airframe is the laser. The laser is a good all-rounder. It's precise, it's smooth, it's fully 3D capable, it's fully XA capable. And in that bag of undefinable aspects of the feel of the airplane, the laser has a very, very broad appeal. It's been making that broad appeal now for years. It's been doing it for years. So when you have an established track record with an airplane when I look at things in the industry and the stuff that we're doing, I tend to look at things statistically. And one of the things that I'm trying to derive from a product is what is the rate of acceptance of this product? By rate of acceptance, when you sell a product to a customer, what's the rate at which the customer reports back and says, this is great. This is a great airplane. I love this airplane. I'm going to keep this airplane. That's acceptance of the product, right? And so the laser just has really high acceptance. The 104 Extra 260 also has really, really high acceptance. Those are peak for acceptance. All of our aircraft have got extremely high acceptance, but the laser for a long, long, long time has been very, very, very high acceptance. Very, very few people have ever made an extreme flight laser and said, it's not for me. So that would be cases of non-acceptance, and they're just almost non-existent with the laser. So we start with the laser as the baseline. It's very simple, symmetrical mid-wing monoplane, flat six. Just it's the basic like barcode generic airplane, right? But it's developed to a very, very high degree. It'll do anything. It'll do that anything really, really, really well. Does it stand out particularly in any way? Well, it stands out in smoothness. It's a very smooth aircraft. It's not the most aggressive, right? It doesn't do any one thing the best of our entire lineup, but the bar graphs are all very, very high for the laser. And so if somebody doesn't know what they want, they don't know what kind of flying they want to do, and they're like, well, I don't know, I might want to fly IMAC, I might want to fly XA, I might want to enter a freestyle. Great. We know what to do with that person. They should get into a laser. It's the all-rounder. Okay. If someone wants to be more aggressive, than that. They say, well, that's fine. I'm glad other people like to have all that, but I like to really fly. I will really want to fly hard. That's fine. You're an NG customer. You're a step more aggressive than the laser. And so you're not quite as interested in smoothness. You're more interested in doing things that make people stop and watch. You're an NG customer. And then maybe you say, well, that's fine for regular people, but I'm extreme. I'm really extreme. I fly like Neil Capillaric. Okay, you're a slick customer then. So now we've gone from the laser and we've gone extreme. A step more extreme is the NG, and we've gone a step more extreme than that is the slick. Okay. Now we go back the other way, and from the laser, then we should look at the 104 extra 260. 104 extra 260 is smooth and it's very, very capable, but it's capable in kind of the opposite direction from the NG and the slick. It's capable in predictability, right? It's capable in smoothness. It'll do some extremely high G. If you watch Tucson, you can see what guys did with the 104 too. But it's got a more buttoned down feeling. It's got a more confidence inspiring feeling than say the slick does. And so, go ahead.
No, I was gonna say that the 260 with my little experience with it and what I've seen other people, it makes things feel easy.
Exactly. So basically, we use the laser, and in most sizes, we use the laser as our baseline. This is the all rounder. If, like I said, if you want to make sure this guy still likes you and he's still your friend, well, the laser makes nearly everybody ecstatically happy. The slick is not as easy a recommendation, but boy, if you get the right guy with the slick, they're going to love it. It's going to be the greatest plane they've ever had. It's got to be the right guy, though. And the NG's in between, right? The 104 260s on the other side. And we can take the whole lineup of all the different airplanes that we do, and we can talk about who the perfect pilot would be for different airplanes that we do. Now, the one thing that doesn't really fit into this nice linear thing is the edge. The edge doesn't fit into this nice linear thing. So let's talk about edges for a second. So virtually everyone has heard, oh, you get an edge for 3D. Edges are the best at 3D. And there's truth to that. There's a lot to that. I don't know that they're easier than something like the 104 Extra 260, which is exceedingly easy for 3D maneuvers. But overall, an edge is a pretty good bet for easy post-stall maneuvering. One of the primary reasons for that is you look at the shape of the wing, and an edge has a net forward swept wing planform, which means that an edge is very resistant to span-wise flow. If you think about an airplane has two wings that come out on each side, and when you rudder it, you pushed one wing into the wind, and you've dropped one wing kind of going, downwind. That downwind wing on airplanes, that's the one that stalls, right? If you think about how an airplane stall, spin, crash, how that goes, usually it's the airplane is ruddered, and one wing is pushed into the wind. Like there's some great videos on YouTube from back in the 1950s and 60s of pilots learning to land the first generation of swept wing supersonic fighter jets. And like F-100 Sabres were swept back so far because they were Mach 2, I think, fighters. And so they have an extreme case of swept wing span-wise flow syndrome. And so you'll see that if they got yawed, crossed up at all on landing, the aircraft would start violently rolling. They called it the saber dance. These videos are really sad because ejection seats were not, that wasn't a developed technology at the time. But you can see what happens when a wing is swept back and you rudder into that wing, and one wing ends up being the downwind wing, and the air is no longer flowing across the wing, it starts to flow along the wing. It's called span-wise flow. Span-wise flow can be our friend or our enemy. If we want to have a snap roll, then we take an airplane whose wings go straight out, we rudder it, make one wing be the downwind wing, and we snap into that wing because that's the one that wants to stall. But if we want an airplane to be resistant to snapping, and we don't want it to snap, and we want it to never drop a wing, then one way we might do that is by taking the wings and cranking them forward so that our downwind wing was actually pointed in the correct direction and the air was flowing across it. It wouldn't be subject to span-wise flow, right? Well, that's what an Edge 540 is. The wings are forward swept, so your downwind wing is still pointed the right direction. So sweeping wings forward is one good way to keep airflow from turning along the span of the wing and stalling. The other good way to keep airflow from turning along the span of the wing and stalling is to put a fence to keep it from doing it. That's why you go back to that first and second generation of supersonic fighters, back before they had computer controls and all these things. A lot of them, like MiG-15s, to keep the pilots alive, they had fences in the wings, right? You go back along a MiG-15 wing, and there's a big sheet metal fence to keep the air from flowing along the spar. Well, we have those too. We put them on the tips. We call them SFGs.
Mm-hmm.
So an edge, right, is a great way with forward swept wings to keep the airflow from turning along the spar and stalling. Or on any wing, you can cap it with an SFG and keep the airflow from turning along the spar. I think back, I've been in this hobby so long. I was, back when we first started flying big electric airplanes, I was in the 1 kilowatt club back when, now it's hard to find an airplane. You couldn't even buy an airplane that's less than 1 kilowatt unless you're buying a part flyer. Virtually everything we sell, even our RXRs are, I think the 67 RXRs are like 2.5 kilowatts. Anyway, I was in the 1 kilowatt club back when you could be on RC groups. And if you could prove that your airplane had more than 1 kilowatt, they would send you a sticker. Did you ever see that? That's
No.
before your time. That's how old I am. So I've been flying since the 1 kilowatt club was a big deal.
Nice.
Anyway, but I remember that the technology when we first started having electric airplanes, big 3D, for a while, for a couple of years there, all of our airplanes started sprouting these fences at me, like the Showtime 90. Remember that
I
airplane?
do remember that one, yes.
Yeah, it had the fences. Well, it's just like the MiG-15. It's to keep the airflow from turning along the spar and going span-wise and stalling. And so we don't need to have those at mid-span anymore. We've got things figured out to the point where we can just cap the ends of the wings with SFGs, and it keeps enough of the wing from turning span-wise that we get all kind of good stability. Anyway, that was a long discursion into span-wise flow, all the way back to even in the big sizes, the edges are a little different. They're more resistant to span-wise flow. You can really stomp on the rudder, and the airplane still remains very benign, very planted. On the other hand, edges are very lively in pitch. So an edge has this dual personality. It can be a stable airplane slow, right? I'm a terrible pilot, and I can fly the 104 edge with total confidence. That's the one I like to go dunk in the pond at and all because it's so confidence inspiring, because it's down. But you get that airplane going fast and it does vicious crankshafts, right? Because it's very lively in pitch, as edges tend to be, because there's a nice long straight leading edge. It's a very immediate kind of pitch response. It's difficult to describe the difference in pitch response from that edge wing, but it's there. It's really, really lively. Would you agree with that?
Yeah. I was actually, before you said, I was thinking about that too. I think the two basic things I think of an edge is maybe three things. I think they tend to, by default, they tend to fly a bit slower, or they have like, you don't have the instant acceleration you would have with an NG that tend to be a bit more slippery. And then you have, definitely more stability at like high alpha. And then you have this like very aggressive pitch response. So when you're doing things like slaps, waterfalls, you get that very, very immediate response.
It makes the edge a really good all rounder, and so in that
I got to fly. I got to fly the 67-inch. I think that was probably like a relatively new one, like the 67-inch edge back in November from Tim when he was in California, and it was a fun little plane. Like really, really surprisingly easy, like knife edge spins and positive knife edge spins, and it was fun.
Yeah, they're a blast. I love them. I don't know how many edges I've been involved in over the course of the career, all kinds of stuff. The little 40-inch that we used to do, for a while, kind of a crazy promotional thing at 3D Hobby Shop. We had a $99 balsa edge we sold for a while. We called it the 99 buck huck. It got shortened to buck huck. Anyway, and so I don't know how many thousands of those things we sold, but if you're going to make a little tiny airplane to introduce people to your company, and you're going to sell it for cheap, and you're going to put it in everybody's hands, make it an edge. That's what I did.
What is up with the jacks? I'm surprised not seeing more jacks these days in general, and in particular with Extreme Flight. Like I still remember, the back in the old days of Extreme Flight, the jacks were a big thing, like the rounded cowl.
Yep.
I'm surprised there's no more Yaks these days. Why is that?
So these these designs, these things, these they kind of ebb and flow. So the Yak is an airplane that was super popular, for I would say the first wave of giant scale 3D flying because, Chris Henson got in with the original Extreme Flight Yak. And when nothing flew right, back in the days when nothing flew, for people that weren't in the hobby back in the late 90s and the early 2000s, I cannot stress enough how bad airplanes flew then. You would have something, it was the latest, greatest aerobatic thing. And if you flew that today, you would not believe how horrible it was. And so, against that backdrop, the Extreme Flight Yak came in just like a bomb, and all of a sudden, this is an airplane that you actually can fly post stall. And it's not insanely bad. It really will Harrier and hover and it'll do all these things. It has low coupling. So that was the backbone of the company, for a long time. The Extreme Flight Yak and the Extreme Flight Extra 300. Those were the two pillars, right, for the company. But Yaks decreased in popularity, right? They have a very particular kind of styling. Either you love them or you hate them, and a lot of people hate them. And so the flat six airplanes, the planes that are modeled on full scales that have flat six engines, 540s, like lasers and extras and MXSs, those took over in popularity, right, during the teens. And the sales of the Extreme Flight Yaks, you could just watch the graphs. They became a less popular airplane. But these things come back. Like another airplane that went away for a while and now is coming back with a vengeance is the Cap 232, Cap 580. And so that was an airplane that was all the rage for a period of time. And it had characteristics that when no one knew how to design a 3D airplane, when that was just an unknown thing, there were certain aircraft that just kind of naturally could 3D. And at the time, nobody knew why. Like, for instance, the Ultimate biplane, when you had no idea how to design a 3D airplane, if you did an Ultimate, it would kind of 3D. Now, we can look back on that and say, oh, well, it had a lot of wing area, and it had an extremely large vertical stab and rudder. And so it wasn't subject to yaw instability that caused roll instability, et cetera, et cetera. And then caps. If you didn't have any idea how to design a 3D airplane, you could do a cap and it would kind of 3D because of the tail displacement and different things. But then there were some bad caps, right? There were some really, really, really bad caps. I remember one time I got asked to do a review for a website of before I had 3D Hobby Shop, I was asked to do a review of a cap. I think it was yellow. And I tried to review this airplane, and this airplane wanted to kill itself so badly. It just wanted to die. From the moment you took off, it just wanted to die. And I finally had to say, I can't review this airplane. This airplane just wants to die. I wouldn't want anybody else to buy this thing. And that it was so miserable. And that one series of caps was so bad that it just killed the design. And then nobody wanted to build them anymore. So now, almost 20 years have gone by. And I think maybe the world's ready for a cap again. And you can see some of our competitors have decided the same thing. So we're going to roll with Terry Wiles' cap design. So here we are in late January doing this podcast. And we flew final factory built samples of the 67-inch cap in October when we were in China, and then we just got delivery of our the caps for the instruction manuals build. So those just arrived via air freight, and then we'll get a container here in February or March, I think, and we'll have the 67-inch cap on there. And Terry did a fantastic job, and of course, Terry is a designer that is known for making really stable aircraft. He's done some monoplane designs for AJ. Before that, he did some designs for PAU. And all of his aircraft, if you ask somebody, what are Terry Wiles' designs like? Anybody that's owned one would say, oh, those designs are stable. They're easy to fly, easy to 3D. But when we announced that Terry was doing a cap for us, we had people online that just blew their stack, just say, oh, that's the worst idea. You'll never be able to make that plane fly right. And I'm
Yeah,
thinking,
some old cap models have just put such a bad name on that. Like it's
well,
so hard. Like it's definitely a big uphill to clean that up, and
well,
to
for a
convince people
couple of
again.
times a couple of times I posted a picture of a doll and I say, show me where the cat bit you when you were a child. Because, obviously people have had a bad experience. A couple of people went so crazy we had to give them a timeout on our Facebook group because they were just going crazy about the caps. Anyway, and we were showing video of the prototypes just harrying around easy. Terry does a great job. Those planes are easy to fly. The people, it's so ingrained in them that cap snap, right? Cap snap. It's so unfortunate that those words rhyme.
Mm-hmm.
Cap snap, that they can't believe that it could ever be done properly, which kind of brings me to a topic. This is controversial, but this is a thing I want to talk about a little bit. One of the things that I think people don't realize, if they have an idea like cap snap and you could never do a cap properly, I think one of the things they don't realize is that if you reduce these airplanes down to their spreadsheets of data, a cap and an SBOC and a Gamebird and a Velox all look exactly the same on the spreadsheet. They're exactly the same. And, a slick and a laser and an ARS and an extra 260, if you reduce them down to their spreadsheet data, they're exactly the same, right? Because you really only have, in the full-scale airplane world, there's really only a limited number of things you can do with an airplane. You can give it a flat engine or a round engine. And you can give it one wing or two. And you can either sit him on top of the wing spar, or you can put his knees under the wing spar. But you don't have an infinite number of choices in full-scale aircraft because you can't run a spar through a man. And there aren't any other kinds of engines for full-scale unlimited aerobatic aircraft besides flat ones and round ones. So, there's a limited number of basic forms to these aircraft. And so, I've always been interested in that, people are dedicated to the idea that, nothing flies like an extra. But, as a designer, if I have an airplane and I've got my wings, my tail, my moments, all of my constants are worked out, my damping ratios, my airfoils and everything, it's all worked out, and here it is in CAD, right? And I'm moving it around in CAD. At that point, it's pretty easy to change the styling. I could make a slick into an ARS, and I could make an ARS into a laser. And, I don't have to change any of the aerodynamic constants to do that.
I guess that one of the challenges with the cap, though, isn't one of the potential concerns with the cap the position of the wing versus the stab versus the longitudinal axis of the plane, like being pretty far from each other.
Just like every other aircraft, every other full-scale airplane in which the pilot sits over the spar. Because if you look at full-scale aircraft, the vast, vast majority of them, the tail section is a box. It's a literal box made of chromoly tubing, covered in usually fabric, sometimes composite skin. But most of these aircraft are metallic frame. Extra 300s are, and caps are, and edges and all these things, which means it's a box, and you have to put the tail plane, the horizontal stab, has to mount somewhere, and it normally mounts on top of the box. If you can't mount it on the bottom of the box, the elevators would scrape the runway. So you can't mount it in the middle of the box. There's nothing in the middle of the box. So, like I said, there's a limited amount of change in form factor that's available in the full-scale aircraft world because you still have to put a pilot in it. It has to balance with the engine, which is either flat or round. You have to put a tail at the back. The tail is going to sit on top of a box. These things start to become very common. And so we actually have a lot more freedom in models. I mean, we have a lot more opportunity to make something fly right than full-scale designers do. Those guys are working with a lot more compromises than we are because they have to put people inside them. We don't have to put people inside anything. So with a cap, so like for instance, so in the 3D Hobby Shop, and then we did a reprise for Extreme Flight. We did a Velox. Mm-hmm. And Velox, everybody loves it. No one knows what it is, but everybody that figures it out loves it. There's certain aircraft that are never going to sell in big numbers because of their name. Again, this is part of where this intersection of engineering and marketing comes in. So you're never going to sell very many of a thing called a Velox, right? And this is just the nature of the game. People go to the flying field. A lot of times they want to have a known good quantity. right? Because part of RC flying is social experience, right? You go to the flying field, you show people your new airplane, you want people to approve, these are your friends, you want to be part of the gang. And so clubs tend toward one brand, they tend toward one airplane. That's the way it goes. And so, you're probably not going to buy the weird thing unless you're the weird guy. You're probably not going to buy the weird thing. And so if you have something called a Velox and you take your new Velox to the field, you're probably going to get asked questions like, what the hell is a Velox? That's not the best way to start your relationship with your new airplane. On the other hand, if you show up with something called an extra,
It's safe.
that has cachet. It's a totally safe choice. Like there are some airplanes in the market right now that have weird names, and they're really good airplanes. I'm thinking of one in particular that's called something like Antique or something, but that airplane, if it had been called an extra, would probably have sold 3 times or 4 times as many units because it's, nothing wrong with it. But on the other hand, if you call the aircraft something which no one knows and no one understands, you've got an immediate problem. You got a barrier
It
now.
feels, I'm not the marketing guy at all, but it feels to me that you either stick to the safe names or you go completely in the opposite direction. You do something totally different, like I can think of the Bushmaster, the Peregrine, things that are also definitely not extra, but they're also such a different model, right? Like you don't have this plane that kind of looks like an extra, but it's called a Velox, right? You have a Peregrine, which is like complete different shape. It's a biplane, totally out there in comparison to everything else you've seen, or the Bushmaster, totally out there. I feel like that's
So you also, you also have iconoclasts. You have people that want to be different, and that's that's not the majority of humans, but it is a sizable minority of humans. And so, you do give them a Peregrine or something like that. But boy, it needs to be different enough that it reflects their personality. I'm not afraid to fly this. I'm not afraid to own this. You have to give something for everybody. But if you're going to produce something that is almost an extra, I recommend you go ahead and make it an extra. That's probably a good way to plan your product. But anyway,
just mentioned, or we're just talking about this like Peregrine, Bushmaster. I'm kind of curious, how different is the design process when you're looking at this type of more straightforward extra edge slick, that these models that are designed after well-known full-scale planes versus when you start blank slate, let's do this like crazy cool looking biplane like the Peregrine. I'm guessing that additional freedom is probably fun, but at the same time it's probably also challenging because now you have so much room for experimentation, right?
Yeah, a lot to say about this. So I want to take a little detour and talk about designers and talk about how they work. So I am what you would call a corporate designer in the RC industry. I work for a company. I'm a full-time employee. Now I've been an owner in the past. I'm an owner of a company. And so I'm designing for a company, right? Which means that what's first in my mind when I'm starting a project is, what does the company need? And that's great because you can get a lot done, and you can, in workmanlike fashion, you can have your aerodynamic design. You can propagate that across different sizes. You can fill in the lineup, of what people want. Your evergreen aircraft. Make sure that the extra 300 is up to the minute, good shape. Make sure the edge is up to minute, good shape. Make sure okay. And that's the work that I do most of the time. And then you have other kinds of designers, freelance. So we have 2 freelance designers that we work with at Extreme Flight. So we talked about Terry Wiles a little bit. Terry Wiles, a freelance designer. And so Terry can do what he wants to, right? Because nobody owns Terry. Terry, he's independent. And so like Terry decided to do the teacup, right? And he wanted to do the cap that we talked about. And so a freelancer, because he doesn't have to have his airplane produced, it's not necessary that his airplane reach production, right? He can do what he wants to, and that with more design freedom. And then the other freelance designer that we work with, someone that takes that principle of design freedom to the nth degree, is Cody Wojcik. So have to talk about Cody, because if you want to have a healthy organization, if you want to have a healthy company, you need to have a variety of personality types, right? And so you have to have a mad scientist. If you don't have a mad scientist in your organization, you're going to miss out on a lot of invention and a lot of inventiveness. So I'm very happy to say that we have a mad scientist at Extreme Flight, and Cody has done amazing things in the past. So he is very well known for two designs. And the Bushmaster is, who would have ever, seriously, who but a mad scientist would ever have said, I think I can take a relatively scale, actually quite scale, turbo beaver, big bush plane form factor, and I can make that 3D aerobatic and sport and stall. I can do all these things out of it. Well, see, that's that mad scientist. Someone who's thinking of product planning. Okay, we have the 104-inch lineup. We need the next airplane for that. You're a little more hemmed in, right? Whereas the freelance guy can just think wild blue sky ideas. And so Cody thought up the Bushmaster, and look how successful it's been. I mean, that has been amazing because it's just kind of a do-it-all Swiss Army knife airplane. Then the other thing that Cody did, which he's very well known for, is the Turbo Raven, right? And the Turbo Raven is one of those cult airplanes. It's an airplane, it's an aerobatic monoplane, so it competes against the Extra and the Edge, right? But not many people have ever heard of a Turbo Raven. If the people have not heard of a full-scale Turbo Raven, go and Google it, because Wayne Handley's Turbo Raven is one of the most amazing airplanes in the full-scale world. It's one of the most amazing stories. The fact that he survived the project is amazing. Go and watch those videos. Turbo Raven, outstanding full-scale project. And Cody channeled that into this weird hybrid 3D and pattern airplane that kind of does it all. And anyway, freelance designer, mad scientist, right? So then sometimes the corporate designer gets frustrated and says, I could do that too. So with the Peregrine, that was what I got the chance to do. So we were over in China. I've told this story many times, but we were over in China. It was 2019. We were over in China, and a lot of times what we try to do, going to China and staying in China for a month and working at the factory and doing all those things, it's pretty hard. China is a really, really nice place to visit and work, and I really enjoy it a lot. But it's very foreign. It's very different. It's not as comfortable as being at home in your home culture. So you're pretty worn out after a month in China. And also, when you're there, you work 7 days a week. You work 14 hours a day, 7 days a week at least, because that's the schedule that the Chinese people keep. I mean, they're legit working 6 days a week, 12 plus hours a day, and then if you're trying to use your very expensive time over there, you're going to work seven days a week, and you're going to go 14, 15 hours a day. So we always usually try to schedule a day or two of relaxation on the way back. So we had stopped in Macau. And Macau is across the bay from Hong Kong. Hong Kong was the British colony back during colonial times, and Macau was the Portuguese colony. And so Hong Kong ended up being the world banking center for a long time, and it's an extremely rich city and has all the tall buildings, whereas Macau is where the gambling is. It's where all the casino hotels are. So we booked ourselves into a hotel casino for a couple of days in Macau just to relax. And so we were there and relaxing and had a few too many pineapple drinks, and things like that. And I had been grousing. I want to do a biplane. I want to do a biplane. I want to do a biplane. And I had gotten to work on the muscle bike, but I'm like, I want to do a balls out, crazy biplane. And finally, we've been drinking a little, and we started saying, we're going to do it. Let's do it. And so I'm like, well, I only need to be told that once. And so I immediately ran back to the room and started drawing. And the Peregrine shape was actually knocked out in about 3 hours. At the Galaxy Hotel in Macau, because I had been thinking about this for a long time and I knew what I wanted to try. And so that was me acting like an independent, freelance designer for a change. And from a economic perspective, the Peregrine took way too long. The prototyping process took years, and it was very complicated. And if you wanted to be maximally profitable, you wouldn't do that. You'd let an independent freelance designer go do that. But I'm glad I got to do it that one time. I got to just spread my little wings and go and just dive deeply into a weird technology. And that Peregrine, okay, so I'm talking about, you can see a designer goes through these different fetishes as things go on. So the Peregrine was me getting to work out all of my idiosyncratic, privately held hypotheses about biplanes and why biplanes do what they do. And so it's designed to be the lowest possible interaction between the wing plan forms. And so if you look at a Peregrine, it's actually a fun fly wing on the bottom and a super tapered pattern wing on the top. And it's designed for the wings to have as little overlap, as little shadow as possible for the minimum amount of interaction. And it's predicated on the idea of shedding interactive vortices as quickly as possible so that you don't blank the tail. And have you ever flown a biplane with really bad blanking, like you put it into a knife edge spin and it won't come out, things like that?
I haven't flown. I would say I haven't flown any great biplanes in
We'll
general.
have to get you on a peregrine and see what you think, see if
I
you
have
like
not
it or
tried it.
not. We got to do that because that's, back years ago, 20 years ago, 15 years ago, companies always try biplanes. You're in the business and you've made your extra and you've made your edge. And then when you've done that, you want to try a biplane, so you do a biplane. And boy, there have been some bad ones over the years. I mean, some really horrible ones. Airplanes that you put into a flat spin, they won't come out. Airplanes you put
No.
into an inverted spin, they won't come out. And what's going on is that something's happening that the tail is not responding, right? And so the interaction of the wings is causing the airflow to go somewhere else besides the tail. And so interaction between the wings is detrimental to flight characteristics. But if you spread the wings too far apart, then you end up with the lower wing can't go any lower than it is. It's already on the bottom of the airplane. But
Yep.
if you spread the wings farther apart, you end up with the top wing getting so far away, now the airplane has crazy coupling. So how do you get these two wings close enough together that you minimize the coupling while at the same time keeping the interactions from doing anything weird? And there have been all kinds of things that have tried. Some of the efforts ended up being really, really good. Like one of my favorite vintage airplanes now is the AeroWorks Ultimate. And there were, Jason Knoll and Jason Don Hockle and different people, these great pilots, worked on that airplane for years and got really, really good characteristics with that airplane. But you could see how many iterations it went through while they worked and worked and worked on these wing positions to keep the coupling low, the interactions low, the blanking low, and while keeping it looking scale. And I said, well, why? The easiest thing to do then is throw scale out the window. Let's call it something else, and let's do a non-scale airplane so that we don't have to fight with those interactions. And anyway, that was the whole Peregrine project, and that was me acting like a crazy mad scientist for a change.
Yeah, it's interesting because there's at least I cannot think of many examples of biplanes that have such a different wing shape between top and bottom wings, right?
Yeah, that those planforms, the way those planforms interact, you can look at full scale biplanes, and there are some that I would want to tackle, and there are some that I would not want to tackle because of how difficult it's going to be to get them to work out. The Waco design that we started with for the muscle bite, we did that project before we did the Peregrine. And that taught me a lot because, before that, I'd only ever done one biplane before, and it was a semi-successful 3D hobby shop park flyer biplane. Learned a lot from that, but mostly learned what not to do. And then with the muscle bite, that was an opportunity to do some real testing and to figure out how to minimize interactions. The muscle bite, actually, that's a really great airplane for us, and it works really well. And it's got some interesting characteristics. That thing, it's an exercise in, can you take a golden age airplane, a beautiful 1940s, can you take that and then can you chop it up and mutilate it so that it'll fly right and people don't notice that you've chopped it up and mutilated it? And sure enough, you can do that because we took that poor Waco. It's a Waco YMF-7. We took that poor Waco apart in 3D space, and then we stuck it back together basically with the decollage and with all of the dimensions of a 2-meter pattern bipe. Right? That's what it is. All it is it's a pattern biplane in a Waco skin. That's all that it is. Because the pattern biplanes have been worked out for years and years, and you can go back to the old TOC. All that it basically is, it's a TOC level biplane in a Waco skin with a Waco cowl, Waco wingtips, Waco tail, and all that.
It's a
But
beautiful plane.
it works, doesn't it? I mean, at the time when we started doing this, like, will this even work? Can we even do this? Will it be a strange looking airplane? But when we got all the pieces assembled and we said, oh, no, that works fine. And, in flight testing, we said, did we get it right? Yeah, it's not as hardcore as the Peregrine. It's not quite as aerobatically pure as the Peregrine, but it's good. It's really good, and it has that classic look. That is a project of all the projects. I'm just about as proud of that muscle bike as I am of any of them, and I love flying that thing. And I finally sold my my blue one, the original 110 that I had, which I flew all over the place, had a great time with. I finally sold it because I'm doing a custom one for myself. So this is going to be my thing for 2025. I'm gonna do. I've got an idea for a custom scheme I'm going to do, and I've taken one of my favorite race car color schemes, and I'm putting it onto a 110 muscle bike, and I'm going to
Nice.
put that DA 200 in it, and I think that'll be the new my
I want to see
my.
that one when it's ready.
Oh, it'll be real fun. It'll be real fun. So that's what I'm going to build for myself for this year. So yeah,
Well, I think we should
again,
chat about some of the new projects that you guys have going on. I think you have so many like cool plans in the history of the company that it's like hard to stop and keep make progress on the chat. But you have a bunch of especially since Team has joined Extreme Flight, it feels like the rate at which you guys are kind of announcing new projects and new releases is being
yeah,
just being really fast. Like every other
yeah,
week there's something new.
yeah. It's so. One of the things that we're doing is we're now trying to establish that Gen 5 aerodynamic package in the lineup, because there's a lot of cool things we can do with that. Now that we have, and it's technology moves on, right? There's always something new happening, and the now that we have this aerodynamic package, which is high performance but easy and gentle, and it's a step forward. Now we're trying to work really hard to propagate that across all of the sizes and all the things. The other things that we're trying to do is, so when we're not that many people. I mean, Extreme Flight's not that big a company. I mean, you're talking about 300 people worldwide that work with and for the company, and our headquarters staff in Atlanta. We're always less than 10 people, and it's most of those people most of the time are completely covered up with doing the business of the day. And so as far as technology, there's only a couple of us that get to work on that. And it's, so we have, hundreds of products, and it can be kind of overwhelming sometimes, because you're like, okay, we're going to do a very simple thing, right? We're going to change one turnbuckle on all the airplanes because we've now found a better turnbuckle. The amount of work that it is to change one thing on all these products, it takes literally years.
It's a big chain. Yeah.
Oh, it's a big deal. Also, we have to have at any given time, we have to have at least a dozen projects in the oven if we're going to have new products at the rate that people expect. We've got to have at least a dozen working at any given time, which means there's a lot to keep track of. So right now we're just at the end. So we're at the very end of the process with Terry's 67-inch cap. That's just about to hit. We're at the very end of the process with the 88-inch extra 260, which I'm really excited about, because that is a whole new kind of a thing for 70cc. It makes 70cc so much better. We're kind of in the middle of the process with the 75-inch extra 260, which that's actually kind of the most groundbreaking aircraft that we've done in a while, because that poor 35cc class has just languished for too long. It's been, everybody dreams about that. People that have never had a gas airplane, they want a gas airplane so bad, and they look at the prices and they say, I'm going to get a 35. And I'm like, oh, you poor person. You don't know how bad it is. It's a low point in performance. If the 67-inch electric's a high point and the 120cc gas is a high point, 35cc is a low point, right?
Yeah, I feel like the smallest gas I usually would consider is like a 50.
Yeah, but that's not what people buy. People buy that 35cc. It's an extremely popular class. Well, okay, because the equipment has historically been bad, the servos that you buy for 35cc are lackluster. The engines themselves are low power to weight ratio to begin with. You're putting heavy equipment, heavy ignition, heavy batteries into this poor little airplane. These things have they've been the stepchildren right? 35C has been the stepchildren for a long, long time. So one of the things that Tim and I did last year, Tim and I said, look, if we're going to do something and we're going to make waves in the industry, what's on our short list? And we both said, well, we need to fix all these problems with 35cc, right? We need to fix them. And so you make a list. What are all the problems with 35cc? And that list gets huge because, most 35cc projects just suck. Terrible. But people wish they were better. And they work better as electrics than they do as gas. But, okay, so with the 75-inch Extra 260, we got to address a lot of the problems with 35cc. And I'm really, really pleased with it because it flies really, really well. And one of the best things about it is it takes anything. It takes 35cc single cylinder, 38cc single. It'll take a 40cc twin angle plug, 40cc twin straight plug. It'll take 12S electric. It takes anything. I love that about it because it'll take any exhaust system. Anyway. It solves a tremendous number of those problems. So I'm hopeful that 75-inch Extra 260 kind of becomes everybody's favorite first gas airplane. Because if they'll stick something decent in it, it flies really well and the hardware's worked out. It's not as much of a DIY project as most 35cc's are. So that's a biggie. That's coming. Anyway, we're talking about the stuff that's in the oven. Okay, so the biggest thing that's in the oven is Terry's giant teacup, 158 inches for 150 to 222 cc. And so this has been an odyssey because doing an airplane that big and that light, because so it's a beast, right? Now, there have been big Cubs before, and you say, oh, you're not the first one to do a big Cub, but it's so light. It's so light. So that thing with the mine, the red one with a DA200 is just like 46 pounds. It's nothing. And so to be that lightweight, that big, and also to have everything worked out with quick latches, it's easy to assemble and all these different things, that thing it's been tremendous work. Terry's done tremendous work. We've had to do work. The factory's done tremendous work. And which we love when people are impatient to get the airplanes. That's the best. We appreciate so much people say, when's this darn thing coming out? We get it. That's what we're looking for.
Excited.
But at the same time, they take a long time, and an airplane that big takes extra long. It's going to be so cool. It's such a cool airplane. And so those will come sometime this year. So that's in the irons in the fire. And then if you've been on Facebook, if you follow Terry, which everybody should follow Terry, he's an amazing
it's really
craftsman.
fun to see.
Yeah, he does stuff in his home shop that you won't believe. But he's now working on the electric, the 85-inch version of the teacup. So that's now a project going forward. Oh, so there's also a bunch of secret stuff that I can't talk about except in very great generalities. So there's an airplane sitting right over here. I'm looking at it, which is the first of its kind for extreme flight. We've never done one of these before, and I'm very, very excited about that. And then there's one over there, which is the first of that kind. We've never done one of those either. I can't wait because people have been waiting for this for years and years. I've been waiting for this for years and years. So, yeah, this is very cool. I can't turn the camera around because it's all top secret. We're also doing some really cool accessories. We've been on, when we were in China, we had a couple of accessories that we wanted to knock down, things that we've had on the list for a long time. Some of them are super secret. You'll see them soon. But the other things are not super secret. But like we want to get deeper into tools and accessories, field equipment, workshop equipment, and so we've got big plans for that. And the first thing is we've taken a work work table, and it's the kind of, this type of folding work table. It's been around the industry for a while. We've put some twists on it. This is going to be neat because we've done some little extreme flight touches to it, and we're also going to be making it more affordable. And anyway, I'm looking forward to see how people like the work table system, because if that goes well for us, that could point the way to more workshop equipment in the future.
Is this the one I might have seen a video of in the YouTube channel?
Yeah, okay. Tim made a real nice demonstration video of it, and it's not a new kind of work table. This type of work table, it's been in the industry. It's a known technology, but we've been able to do it a little nicer, and a little more affordably. So I'm excited about that. That's going to be good. And then we're doing doing some new accessories. Trying to figure out what can I talk about. What have we announced? What can I talk about? I'll think about that for a second. We're keeping a lot of stuff secret right now, which is fun. It's always fun to have some secrets. One thing I can talk about, which is coming up. So we're doing this in late January. Chinese New Year is a big deal in the RC industry. Most of our quality high-end production is in mainland China. And a lot of it also is in Taiwan, and both of those nations celebrate the 3-week-long Lunar New Year celebration. It's already started. It's going. China is having a big party. We're headed for the giant Chinese hangover, and then that ends during mid-February. And so then during this period of time, the industry kind of shuts down R&D on the Chinese side. I'm still, I can keep stuff going on the U.S. side. But then new projects tend to emerge after Chinese New Year. And so we're going to be showing some stuff this year. So production of the chipmunks is coming after Chinese New Year, so that'll be in the late spring. We'll be getting those in early summer, and those that's the 81 inch. I forget where it ended up. We had so many different wings. That's the 6S 5000 powered or 6S 6000 powered chipmunk, which we showed last year, and which apparently is going to be very popular because everybody
looks cool.
Really responded.
Yeah.
Well, yeah. I mean, it's a chipmunk, which is cool, and then it also does 3D like an elephant doing ballet. It's anyway. So yeah, it's very easy and very fun and very weird, and people appear to be excited about it.
I remember when I was a kid going to some like RC store near home and seeing some like, I don't know if it was a Carl Goldberg or some like probably the plane didn't fly great, but it just looked cool. I remember seeing it in some magazine. I really wanted one of those. So now having one of these,
well, that color scheme. I mean, that color scheme is so iconic, and yeah. So you have to. So we're doing one of the schemes is going to be a nod. We're not actually doing the Art Scholl scheme exactly because we didn't do that chipmunk exactly. There's a customer of ours, actually a guy that's a customer and part of our Facebook forum, and is a guy named Mike Morton, and he owns a super chipmunk, which is painted in an homage to Art Scholl's color scheme. But his chipmunk has a very nice, custom, smooth, flat engine cowling. And if you haven't ever seen it, you should look up Mike Morton's chipmunk. We've got it linked on our Facebook site in various places. And N540SC is the N number. And you can just look up N540SC. That is a badass little airplane. He's just got such a nice airplane that he's done. And so we've modeled that airplane. It's really smooth. Everything's very nicely put together. And so we did that. And then we're also doing an homage to a military trainer scheme. We're doing a yellow, a bright, high visibility yellow. Now, the cool thing, so that airplane is done and it's in production. And I think it's going to be successful. I never like to count my chickens until, they're in nugget form, but I think it's going to be a success. Then, if it is a success, we're coming on fast. We should be deep into prototyping. By the end of spring, we are doing the 114-inch version of the chipmunk for 120cc. And that I'm excited about because not everything needs to be a hair-on-fire aerobatic competition airplane. Sometimes you can have something that's a little bit slower.
No, the kind of plane on that size with a gas engine would be really, really nice.
Yeah, so this is one of the things that I'm doing with this airplane is I'm making sure that we have tray space and the trays are situated so that we can carry 100 liquid ounces over the CG, 50 fuel, 50 smoke. So with a 120cc engine, that should get you a nice, long, smoky flight. And so this is the kind of airplane we want it to be. Not the highest performance anything. But it has flaps that are mixable with the ailerons, like the small one. And we have some work to do on this because we have to make sure that the chipmunk has its landing gear attached to the wing near this. It's outboard from the fuselage, so the wing is multi-piece. And on a 120cc airplane, this requires some work. to make sure that it's properly stressed and that you can put it in a trailer by yourself. It's not a pain to have the airplane. So anyway, all of this we're working on all of it, but I can't wait to show that airplane. That's going to be extremely cool.
Yeah, it's really cool. I'm really, even though I love obviously like aerobatics and 3D and XA, I really like this, like the Bushmaster, the TCAP, the Super Titmag. Like they're very unique.
Yep.
They're very it's a different type of fun, and I like that they are, even if they're not extreme, they seem to let you do enough fun stuff that it's even for an elite pilot still could be different way of having fun, right?
So back when I made my living in auto racing, one of the jobs that I had for a while, I worked in vintage auto racing, and vintage auto racing is big money, huge money. I mean, for Ferraris, Ferrari after Ferrari after Ferrari, and I took care of a particular auto collection, vintage racing collection. But everybody that owned all of these expensive vintage racing cars, they all had a Fiat. They all had a Fiat 500. And so after they had spent the day driving their million, $2, $3 million Ferraris around, in the evening, what all of these, very successful guys would do, they'd all get out their little Fiat, crap box car, and they'd all go race their Fiat. And they had much more fun driving their Fiats in the evening than they did racing their Ferraris during the day. And I think that planes like the Bushmaster and the Chipmunk and these things are like that, is if you've had your hair on fire all day and you've been, because, even when it's not an organized competition, going to the flying field's a competition. Come on. So what we do, we're pilots, most of us are males. We're going to go out and compete with other pilots. And so after all day of having your hair on fire and showing the other guy that you can rotate that plane just a little harder than he can, it's nice to get something out in the evening that's a little more gentle. And boy, that market has been really good for us. People. Oh, speaking of that, we're also doing during 2025 at least one new size of muscle bike. At least one new size.
Nice.
Yeah. So that airplane is super. We can't keep that in stock, and so we need to continue to expand that. I enjoy it a lot. And the other thing that's coming is the 120-inch Extra 260, which I'm sure you saw from Tucson coverage.
And I thought it was cool that you guys seem to be doing like two slightly different versions, kind of targeted towards IMAC versus Freestyle, right?
Yep, and we can do that. It's a pretty well-known technology. It works well to do it only with the tail, only with the stab, only stab and elevator, because all we're looking for there is how much dig the airplane gets on a pitch excursion, right? And we don't want the same kind of dig for IMAC maneuvers where we're trying to demonstrate pitch as opposed to digging as hard as we can for 3D rotation. It's two different jobs. It requires two different sizes and forms of elevator. So that's actually what Tim and Santiago are doing right now. I don't know if they were working on that tonight. They may have been this evening, but if not, they'll be doing it this weekend, is flying back to back with several different stabs. We got a bunch of stabs. And we're going to be; those guys are going to be testing. So the testing is constant. But that was neat, because even without really being developed, even without having a bunch of work on it, because that project, it was right up against the wire for whether we could even display that airplane at Tucson, right? And it was like, okay, we said, what are we going to do? Well, it's important. That's a gathering of the people that will be interested in the airframe. So that's one. So let's take the airplane and let's at least show the airplane. And Santiago managed to win a round. I was so excited about that, to take an airplane that was pretty much just his and my ideas, because I worked with Santiago on that airplane because he's got so much experience in that particular area. And I'm like, let me be your scribe. And we talked airfoils for a long time, and we talked areas. And anyway, so that was great. Again, I like collaborating, and collaborating with Santiago was another great experience. And so we drew that one up, and we finalized everything, and then we got the samples built, because again, some things we can do in the home shop and some things we cannot do. We have to have recourse to the equipment at the factory. Prototyping a giant plane like that, we got to have recourse to the factory equipment. So we had a couple of samples built up from these drawings, got them over just in time. Tim was actually still bolting the engine on one of them as they were in the parking lot getting, it's one of those kind of deals. But we got it there, and we thought to ourselves, we said, well, it's good. We can let some people see it. let a few guys fly it a little bit. We'll get to fly it for the first time. And darn if Santiago didn't take a round with it, which I'm super proud of. They really made me happy.
It's a pretty good sign.
Pretty good.
Something he also knows how to fly, so I'm sure that helps a little bit.
Oh, yeah. Oh yeah, but it's nice to have a little bit of initial success, and then the development has gone on, and we're on to different wings, different ailerons, different tail, different rudder, different things. But that's the kind of normal development that goes on.
The other pretty recent release I think I've seen is the 49-inch new airframes, right?
Those things are tremendous fun, and that project was fun because you know, sometimes you wait and you're waiting for other parts of the industry, and you knock on the doors of servo manufacturers and you say, please, we need a micro servo that really works. Can we please finally have one? And they make promises and things, and you get it, and you're like, oh well, okay, it still doesn't really work. And then finally now we have power systems and servos. It's like the skies have opened and the angels are singing, because now we have power systems and servos for 4-foot park flyers that work as well as the ones for 60 and 67 inch. It's great. It's fantastic. So once you have that, then you can design a good airplane around it. So those little 49s are so much fun because you're not fighting centering all the time. The story of park flyers before that is, you can have the greatest park flyer airplane there ever was. And, I've taken my shot at designing some. Other great designers have taken their shot at designing some. And the whole thing it's always, well, it can only be so good because you're always fighting centering, right? Or you're always fighting blowback, or you're always fighting weight. And now, finally, we've got those little 49s with that 6S T-motor power system. It's just gobs of power. And then those new little Theta 921s work so well. We have actual aluminum arms that look just like the larger aluminum arms. It's so cool. So, and I think you can. There's one over there. I think you can. Yeah, there's a laser. Mm-hmm. And that little laser. I've got that one set up on 4S, which it's great. It's great on 4S, but then most of the other testers are set up on 6. And so if people want the hot ticket, get the RXR for 6S. Get a 6S 1800 2000. It'll carry a 22 if you want, but get something 6S 1800 2000. It's a trip. It's such a good airplane. You won't believe how good it is for the size that it is. It'll fool you a lot of times. You'll think, this reminds me of a 60. Am I flying a 60? Or am I flying a 49? And that's exactly what we're going for there. Yeah,
cool.
They're great.
Yeah, I can imagine that one being pretty popular too. It's like a good entry level cost with the performance that you would want on something bigger.
Well, and now, speaking of entry level, now we can do RXR, and it's so great because if somebody wants to get into high performance aerobatic airplanes, one of the barriers there is setup knowledge. Right, it's a big barrier. How do you learn setup? How do you do these things? If somebody can get a hold of one of our RXRs, then most of the setup is done for them. Right, it really bridges that knowledge barrier, and they only have to have one. If they do one RXR, they learn everything they need to know. From that point on, they can get ARFs. They can choose their equipment. That RXRs have turned out to be the best teaching tool we could possibly have had for getting people involved in this part of the market. Because if somebody gets a 67-inch RXR or a 60-inch RXR, now one of the new 49s, they know what the airplane's supposed to look like. They know what it's supposed to feel like. They know what it's supposed to fly. All of those questions are just gone. Whereas in the past, a lot of times if you sent an ARF airplane, a high-performance ARF to somebody, and they weren't part of a big club, the questions that they would ask is kind of like, well, what's it supposed to feel like? Well, they don't know what it's supposed to feel like. How can you describe that? Is there
or they make a lot of basic mistakes that make sense that they make them because when you're coming from some E-flight foam model, and now you for the first time have to be setting up choosing servo arms and setting up geometry and things like that once you've done it a couple of times and you understand it's not that big of a deal, but the first time you don't even know that you should be worrying about that. It becomes a big deal.
Yeah, the RXR has been so good for that. We can get people into the family, get them into the brand. Even if they have really low experience, they'll have success, and that's what you're looking for. Again, that what is your acceptance rate of the product, right? What percentage of customers are glad they bought it, have a good experience with it? And with these RXR aerobatic aircraft, it's just virtually 100% acceptance rate. It's fantastic. Fantastic.
One
Oh, go ahead. Yeah.
one thing I've been enjoying when you post about this from time to time is your kind of tool time with Ben in Facebook.
Yeah.
I'll admit I've gotten a couple of things from Amazon after seeing your posts. I'm kind of curious. I'm pretty sure you have like a pretty nice setup over there. You're building. I mean, this is your job, and you're building prototypes on a regular basis. I'm kind of curious for the average modeler, average extreme flight owner. Do you have any particular tools that you think more people should have? Everybody has a couple of like things that they use on a regular basis, but sometimes there's these slightly less known tools that are particularly nice to have when you're putting one of these planes together. Yep.
I talk about this a lot. This is, and Tim actually introduced me to this version of this. I think most of us have had cordless screwdrivers before, but Tim introduced me to the gyro-operated cordless screwdriver, where the activation is according to how you're holding it, and you can. I would recommend.
It's pretty nice to use. I have one of those. I have the exact same model.
Yeah, and the DeWalt is the expensive version, but people find them at other brands that are cheaper and everything. But the number one tool recommendation, because if you're doing ARF aircraft, what are you doing? You're driving internal wrenching screws, right? You're installing servos. That's the number one thing. And there's just a few other things. Safety exactos, right, that can't roll off the table and stab you. That's a biggie. And then my only other thing I recommend to people is I recommend for cutting covering, for doing covering jobs, these rotary cutters, which, my wife always has these around for cutting fabric when she's doing her fabric stuff. And I stole one years ago, and it's like the greatest thing in the world when you're covering. And I keep one of these around all the time. If I start talking about tools, I'm a little bit obsessive. And so I have to be kind of careful about, what I'm recommending, because I've been collecting this stuff for decades, right? And so, because I've been collecting this stuff for decades, I don't want to, get snobbish or something and say, oh, you don't have a belt sander, you don't have a bandsaw, you don't have a laser cutter. The idea is that you can get one of our RXR aircraft, and all you have to have is the most basic set of drivers. It costs $15 on Amazon to get a set of drivers. Mm-hmm. And if you have that and a bottle of glue, you're there. That's all you need. And then all you need to do one of our ARF aircraft is you need that same set of drivers, you need that same bottle of glue, and now you need an X-Acto knife, and you're good, and you're set to go. And then if people want to get into something deeper, if they want to get into serious repairs, that's where the tools really come in. If somebody wants to get into serious repairs, then they can make a decision, because it's not that expensive to buy a wing. It's not that expensive to buy a tail. And, in terms of what you get out of, it's not that expensive to buy a small airframe in terms of compared to, other hobbies and things you can do in the amount of time enjoyment you get out of it. People don't have to learn how to repair, but if they want to learn how to repair, that's when the tool thing becomes important, right? To understand when you use a saw, when you use a knife, to understand what different types of glues do, If I were going to pick two tools for anybody to buy, the gyro-operated screwdriver, and if you haven't ever had a knife like this, if you haven't ever had a round knife, you won't understand why I, an old man, like this so much, because sometime during your modeling career, you're going to put this down on the table. It's going to roll off the table, and it's just like peanut butter. It always falls. The bread falls on the peanut butter side. The knife always falls tip down, and it always falls and hits you in the foot. And that's why this is what you want. You want the kind of knife that you have good control with, and it can't roll off the table.
Yeah. Both are relatively affordable.
Yeah, and that's not being snobbish. I mean,
Yeah.
obviously, there's all kinds of tools in the shop and all kinds of stuff. And I mean, I've got a $800, 3D printer, and in the other room is a laser cutter, and there's all kind of stuff going on. But that's for prototyping.
Yeah.
That's for building new parts and doing testing on things. The average person, I would think that, for getting into RC modeling, if you're going to go electric and you're going to get a electric airplane, your charger is going to be your big investment. Couple, three lipos are going to be a big investment. Other than that, maybe $100, maybe, and you can do basic repairs. You can do all your assembly, things like that. Because now we don't need throw meters anymore. We use cell phones for that, right? There's all kinds of things we don't need anymore, and we don't need a lot of measuring tools because all of these pieces are now self-jigged. They all go together. You don't have to do a lot of measuring. Yeah, you don't have to. I love tool time. I love talking about tools. Obviously, I'm a complete tool whore. That's the way to. But it's important to note that that's not a barrier to entry for RC flying. You don't really have
Agreed.
to own any tools. No, no, your radio system is going to be, I'm representing, um, but your transmitter, you should spend your money on a good radio system, one that you have confidence in, one that you've seen other pilots that you trust fly, and one that feels good in your hands. That's important to spend money on. Get enough lipos that you can fly, get decent practice. If you're going to go gas, get a decent engine, good brand, things like that. Tools, not that big a deal.
Outside of actual, I'm gonna work testing this new prototype type thing. Did you ever get to fly just for fun these days?
Oh yeah, I sneak out. So it's interesting. It's the I'm so addicted to flying, and but this is an interesting thing. About 5 years ago, I got cataracts. I got early onset cataracts when I was in my 40s. And when I was younger and working in auto racing, I did a lot of fabrication on race cars. I did a lot of TIG welding. And I used, at the time, we thought it was a great invention. It was the auto darkening welding helmet, where when you start the welding arc, then the helmet turns dark with LCD screen. But as it turns out, that first generation of helmets didn't darken quick enough. And I was actually burning my eyes every time I welded. Well, then when I was in my late 40s, I developed cataracts, and I actually went legally blind for a period of time because I had cataracts. Normally, it's easy to get cataracts fixed, right? People get them fixed all the time, except I got my cataracts right before COVID.
Oh.
And then period of time when you couldn't get any elective surgeries and nobody would do that kind of stuff. So I spent years, literally years, not being able to see anything. And I bought giant, huge monitors for the computer so I could still see what I was doing so I could keep working. It was a crazy time. So for about 3 years, I couldn't fly. The amount that you lose, the amount of skill that you lose if you take a break like that is amazing. And so, like you talked about how, I'm a sandbagger. You've seen some videos of me flying before. Yeah. At one point in time, I had built up some skills. Going through that period of time when for about 3 years I couldn't fly at all, the amount that I lost was just amazing. So for the last couple of years, it's been a struggle. A lot of sim flying. Let's talk about sims for a second. Simulator is the greatest thing ever invented by man. Flight simulator is the greatest thing because I don't know if I could have gotten it back much at all if I hadn't had recourse to the simulator, because the problem is, how do you start again as a beginner? I already own these expensive airplanes, big gas airplanes, and if you suddenly, you don't have confidence in your eyesight and you've lost all your skills, how do you restart? The sim. That's how you restart. So, I tried to be logical about it. I went into the sim and I just started flying drills, like flying circles and flying figure eights in every orientation, right? Upright, inverted, knife, 45 left high, 45 right high. And so that I just did drills on the sim. If you haven't been flying for a while, flying a figure eight, right, with, now do it left wing high, now do it left wing 45. Well, that makes you think and it makes you work. So it's been a process for the last couple of years of trying to get things back. And also, my eyes have been getting better and better. And so now I'm just starting for the first time since 2019. For the first time, I'm starting to feel confident about flying again. And so I've been hanging out at the field more and spending more hours, and it's great.
Yeah.
I missed it so much. Oh my gosh, I miss flying. That if for an RC guy that's been in it his whole life to not be able to fly, but that's bad. That's bad. I mean, I actually that becomes a that you can get into a depression if you fly a lot and then you suddenly can't. Oh, that was bad time. So, but
Well, good to hear
I'm
that's getting
back.
better.
Yeah, I'm part way back. I mean, I'll never be as good as our team pilots. I won't be as good as you, but I'm having a good time, and I've got most of the low slow 3D back now. Most of it's back. Yeah.
So when you go to the field, what do you end up usually flying? Do you go full extreme flight, or do you fly something else these days?
Oh, if I'm not flying extreme flight, I'm flying something else for a reason. I'm flying it because I want to understand it better, and so one of the things I did is, especially because I'm coming back with my skills, and my eyes have been so bad when it became apparent that we were going to enter into the turbine jet market first with Skywing. I knew that that was going to be an issue for me if I wanted to participate. So I went and bought some foamy EDFs and took Terry Wiles' advice, and I put some long delays on the throttle channels and started, training a little bit for turbines because I hadn't done that in a long time. But things like that. And I think like everybody, I've got my couple of weird foam airplanes. Just you go and toss around foam glider, something like that. I had one of those 3-meter Fox foam gliders. And weird things. But if I'm not flying a weird thing or flying extreme flight, occasionally I'm flying a competitor's aircraft. Always try and keep tabs on what competitors are doing. Every now and then, buy a competitor's airplane, build a competitor's airplane. Just see what's the state of the market. What are the other guys doing? And buy a used airplane, something that And so you got to do if you want to stay current, you got to do a fair amount of that, right? You can't be in a bubble. You can't.
I actually wish that more manufacturers did that across the spectrum, whether it's like airframe manufacturers, radio manufacturers. I feel like, in my experience, people that work in these companies don't do enough of that, and they are just they just know what they use, and they take a look at some other
Some
planes in
do.
some
I
event.
mean, there's you can find people that take things seriously, and then you can find people that are just marking time. They're not working. Every industry's got people like that, and even the auto industry, multi-billions and billions of dollars, it's hundreds of times larger than RC. You can still see companies that they don't ever look out the window. They don't look what their competitors do, and then others do, and they're super competitive. And anyway, but yeah, you gotta if you want to do this right, you got to stay on top of what the market's doing, and you got to stay on top. There's if I sat in my little lab and said, I am the greatest, I know more than it. No, that's a way to ruin. That's a way to failure. If instead you start out every day and saying, there's guys that are better than me. They're out there. They're working right now. They're thinking of things I haven't thought of. I've got to be more inventive. I've got to work hard. Okay, that's the way to success. Humility is the way to success. Arrogance is the way to failure, right? Don't ever start thinking that you know everything, and don't ever start thinking
Yeah.
you're the best. Always start every morning and say, I'm behind the 8 ball. I'm going to have to win today. And that's the way to succeed.
When you wanna go just for fun with an extreme flight plane, what model is your go-to?
67. Yeah, 67. Although, so I flew 67s a lot during this whole development process. And so I made a point that after the 67 development was pretty much done, because now the NG's in production and the slick is coming, and we can take. And now Terry finished up the cap, so we can take a break on 67s for a while. I went and built a couple of 60s because I hadn't flown 60s in a while. I'm having a blast, man. Having a blast with those 60s. I've got a 60-inch laser over there, and I've got a 60-inch NG right there, and I've been flying those two a lot. So 60 or 67 is the grab and go airplane. And then when I get to fly anything I want to, just fly anything I want to, 110-inch muscle bike GA200.
That must be a cool one.
Oh, it's so nice. It maybe that's my favorite. Maybe that's my
What
favorite.
engine do you have in that one?
DA200 4-cylinder.
Okay, the 200.
I got it. That
Nice.
may be. I mean, so that's maybe my favorite airplane, and yeah, I'm just gonna stick with that for right now. Probably my favorite airplane of all time is the 110-inch muscle pipe. It just, I don't know, hits me in all the right ways.
Other than all the different releases and new projects coming up, I think the other big thing for people to watch out for is that Wings Over America event, right? Coming
Yep.
up in what is it, April or so?
Yep. Yeah, first weekend in April. We published a couple of things about it on Facebook. We'll start to ramp up the advertising on it, but yeah, everybody should come to that because we run the event the way we like events to be run, which is minimum BS, maximum flying. So you don't have to jump through a lot of hoops. We keep a cheap landing fee, and it's basically just open flying all day, every day. If you haven't ever been to that field, have you been to Hodges Field? And see, you need to come to this event. You need to fly down to this event, and you need to fly at it, and it'd be a good time. That field is so beautiful. So Mac Hodges is one of the great guys of the hobby of the industry. Hodges Hobbies was his private hobby shop on his private amazing flying field. The whole thing is like it's like 50 acres of putting green. It's amazing. It's the nicest facility. And now the hobby shop is closed down now because Max retired, but he still lives on site, and the place is just immaculate. It's for an RC guy, this is what you hope heaven is like. You hope that this is what you get to spend the rest of the time doing because it's just on the perfect smooth grassy field in the perfect weather. Oh, it's so great. Yeah, come to Wings Over America, and you can watch me crash something, and you can watch all the rest of the guys fly well, and we'll have a good time.
I have seen some videos of the prior years events, and it does look like a sweet place and like a really fun event.
Yeah, it's just a laid back event for extreme flight guys, and we're not very, we don't enforce that or anything, but it ends up being mostly our customers, and
Yeah.
and it's just a good fun time. We normally, we'll show something, we'll show a new release. I don't know what we have planned for that this year, but I'm sure we'll do something. And
I'm sure Tim has something planned.
yeah, exactly. Tim does all the planning for the events. He runs the roadshow. He does a great job, and so he'll figure something out. I come out of my lab, blinking into the sunshine at the last minute, and I'll show up and crash something, and I have a good time too.
Well, I think this has been super fun. I don't want to keep you here any longer. It's been like already really long. But this was really fun, at least for me. It's really fun to just nerd out about airplanes with somebody like you.
You made the classic mistake. You let Ben start talking about airplanes, and you couldn't
No,
couldn't
not a
shut
mistake
him
at all.
up. So, no, this is great. I appreciate it. I hope it wasn't too geeky. I always wonder if I do something like this. I wonder that I've geeked out too much, gone too much into theory or something. But anyway, maybe for people that are listening to the podcast, maybe it's good that they know that there are terrible nerds in caves thinking about this stuff for them.
I think it's really cool to see all that, all the thinking and all the processes that happen behind the scenes. The plane that you receive in a box. There is a lot of work behind that.
Yeah, well, there have to be obsessive guys like me, Tim, the guys that work at Extreme Flight, the people before us, Chris Henson, who founded the company, other people that run these other companies. There have to be these obsessive types, right? If you didn't have these obsessive types, someone who's so weird that he can start talking about model airplane technology, and 3 hours later he's still. If you don't have those kind of obsessive types, then you won't have this march progress of technology, right? So, in this ecosystem of all this stuff, there have to be these niche companies. There have to be these obsessive type people that's all they think about all the time. Anyway, we serve our purpose. It's good to keep us, away from the public, keep people safe from us, keep us in our labs. But I think it's good that we exist.
Well, thank you so much for taking the time. I really, really appreciate it.
Yeah, thank you very much. I've enjoyed it.
Okay. Take care, Ben.
Right, bye-bye.